session right now. Go ahead and move it to session 1. And I will be doing a small presentation tomorrow morning at the introduction to introduce what Bioresources is all about. Most of us in this room know what Bioresources are. It's really the new name. This conference used to be called the Bioresource Residuals Organics Residual Symposium, but we included the term bioresource because it's not in statute anywhere. And what it represents is a collection of all of our activities in water, air, solids, and the organic residuals management. And so we're going to do a whole survey over the next 2 days of all the different facets and aspects of bioresource management. And we're going to begin with a session of a review of SB 1383, because as most of you know, SB 1383 is what we're all trying to implement statewide in our various jurisdictions. And it really represents the closing of the loop in organics residuals in the bioresources. So we're going to start. Our opening session is going to include the update on SB 1383. And I'd like to introduce the moderator of that. Most of you know Greg Kester, who is the biosolids manager for CASA, the California Association of Sanitation Agencies. Thank you. Go ahead, Greg.
Thank you, Dan. It's a pleasure to be here and see everyone, some of you in person and others online. And we're going to modify our order a little bit, giving our speakers a little time to get here. But we'll start with Jason Fick. Jason's been in the water wastewater operation since 1992. He has an associate in engineering from Sierra College and started with the city of Roseville in 2001. Currently, Jason is the wastewater operations superintendent for the environmental utilities Grade 5 California wastewater operator. He's been since 2009. And the city of Roseville is doing some amazing stuff. I was there yesterday and got to see it in person. And with that, I'd like to welcome Jason.
Well, thank you all for coming out, and for those that are tuning in online. It's my pleasure to be here and talk about something that we've taken us many years to get to. Excellent. Oh, there we go. So I'm sure most of you know, but Roseville is just a medium-sized city. We're about 15 miles northeast of Sacramento here. We about 20-minute drive down 80. We straddle 80. And as you see here, the city of Roseville, our limits are in the black bordered area here, but both plants we have are regional wastewater treatment plants. We have, the regional facilities. We take a flow from Rockland, Loomis, Granite Bay, Newcastle, and the unincorporated areas of Placer County. We are on the southern edge of Placer County, and you can kind of see our sewer shed is there outlined in the purple dotted line. Here's our two wastewater treatment plant areas, that the sewer sheds that we have. In 2020, when this map was developed, Roseville, we served a population of 151,000 people. Our total service area was over 235,000 people that residents that contribute to our flows. And if you can tell on the slide, the Pleasant Grove, the blue area, is mostly under development. We're still looking at bringing in more houses, neighborhoods, shopping centers. So that area of Roseville is growing rapidly. And here's an aerial view of our treatment plant. This was taken just as construction was wrapping up in this over the summer, or actually last spring. You can tell by the green. But this is what it looked like a couple months ago. Pleasant Grove was commissioned in 2004. We brought it online, and this is basically what the plant was. It's a simple design. It was developed and designed to be manned by 10 hours a day, and then our Dry Creek facility watches the plant and monitors it for the next 14 hours. So in the lower right-hand corner is our IPS station and grit removal, and that flowed into our oxidation ditches, extended aeration, wrapped around to the secondary clarifiers. Next to that is just tertiary filters. In 2008, we upgraded to UV disinfection and moved away from the chlorine contact basins. And then during the summer, probably about 80% of our flow is then used for recycled water. At this time and during this design, all the solids that we collected or made, activated sludge, we would dewater and send that directly to the landfill. Because Pleasant Grove is in a newly developed area and it's developing quickly, the modern water conservation efforts are really having an impact on us, so much so that our organic loading outpaced our hydraulic loading. In 2004, when this came online, the plant was rated at 12 million gallons a day of average dry weather flow. But because of these conservation efforts, we were downgraded to 9 million gallons a day. So somewhere before 2015, we decided to embark on a campaign to regain that our lost capacity. We talked about doing a lot of different things, how far outside the box do we want to think, and the idea was just we continue on and make it more of a conventional treatment plant. So one of the things to get that capacity back quickly and economically and make it easy for operations was just to put in some primary clarifiers. So we put those primary clarifiers in, and here that is, it's under construction. Primary clarifiers are the bulk of our capacity. What we get back, that reduces about 50% of the organic loading going into our oxidation ditches. And here we got 4 primaries we built. They're online. Each primary is about 200,000 gallons capacity. All those solids are collected. And usually, typically with a primary clarifier, you need to treat those solids. So up top, those are our new anaerobic digesters. So we brought in we bring them in. We built 2 anaerobic digesters. Each of these digesters is a 1.65 million gallon tank. In the center there is our digester control building with a pump mixing and the heating and our boilers. And up on that right-hand corner there is our solids thickening. So all the WAs that we create in our oxidation ditches, now we get to thicken and send that to our digesters, which was a major boon for us because now all the solids that we're creating on site, we're able to anaerobically digest, and now we're meeting our 503 regs of Class B biosolids. So everything that's developed or made and on site, we're now dewatering and we're sending to the Central Valley to be used for land application for the feed, fiber, and crops. And this was we decided that we wanted to do something with the methane gas that we were producing on site. And we saw that we weren't going to get enough methane just from the organics that we're going to digest on site. So we decided to build a high strength waste receiving station. And so now we have one vendor that we work with who goes around to the restaurants and they collects and cleans the grease traps and brings in all that fog, the fats, oils, and greases. We offload it into our these holding tanks and slowly feed about 10 gallons per minute into our digesters. And that really boosts our gas production. We're seeing about a 50% increase in what we anticipated, what we would just get off a regular digester gas. So, and this is kind of where we start getting a little bit different. And this is where we took the opportunity to really think outside the box. So now all the gas that we're generating on site, we are sending over to our, what we call our energy recovery project. And I'll show you, but we're creating electricity for the plant, and we're also creating vehicle fuel. So first, we take the gas and we run it through, we pull out the H2S through these H2S removal vessels. We compress it, drop out the moisture, and remove some siloxanes. And that's how we condition the gas. But then it goes to another step where we actually upgrade it, and we're pulling out the VOCs, we're pulling out the CO2, and we're getting it up to about 98% methane content. So it's about what natural gas would be. And that's going into our fueling station. But as we clean that gas and we upgrade it, there's a tail gas. So we take that tail gas and we sweeten it with a little bit of a natural gas, and we're using it to run these our micro turbines. And these micro turbines also can switch on and take all of the natural gas, all the methane, and run at full capacity when our vehicle fueling station is full, when our storage is full, or if for some reason it's down for maintenance. Right now, these micro turbines are producing on average about 20% of the energy we need for our plant. And then we have the storage facility and we have 13 refuse trucks right now that are CNG trucks. I can step back and say one of the things that really makes this project successful for us is that the city of Roseville is a full service city. We take care of our own gas, garbage. We take care of our own garbage, water, wastewater. We even have our own, right across the street from this facility, City of Roseville has its own natural gas fired power plant. And so we were able to piggyback on some of their contracts to get natural gas for these facilities that we need for maintenance. So right now we're doing, the fleet is 13 garbage trucks that with natural gas, but because of the clean fleet initiatives is a procurement that we've already, the solid waste has entered into contracts, and they're gonna expand their fleet to 35 vehicles as soon as we can get those trucks rolling in off the line. So we'll be doing all of these trucks with our fuel. So this was a kind of a two-stage project that ran concurrently. The thing that kicked it off was the PG expansion project, where we identified that we wanted primaries. We'd have wastewater solids we have to deal with, the anaerobic digesters that would create gas. And then the energy recovery project kind of came along right alongside of that and developed. And when we decided what we wanted to do with the natural gas, as we figured, are we gonna send it to generators, microturbines? Do we want to do vehicle fuel? At the time, with the RINs and the LCFS and the different grants for clean energy, vehicle fuel made the most sense to go. So we brought in the high strength waste. But because of people who are pretty smart and had the foresight that we decided that we wanted to do the energy at the same time, we've actually put ourselves in a good position to pivot depending on what the the Advanced Clean Fleets initiatives, how that actually ends up panning out over the next couple of years. We can actually go and start creating electricity for ourselves, maybe take care of, we're looking into doing the e-RINs. And so we're in a good spot to pivot if we need to. And since I've gone through this presentation pretty much without any kind of numbers or graphs to make my engineering friends happy, this is the vehicle fueling report for October. And you can see that we're on the weekdays, we average about 11 trucks a day of fueling. We're getting up to 13 when they're running all their trucks. The weekends, we're dropping off to 1 or 2 trucks a day. But over the course of October, it was 247 trucks that we filled. And we did about over 8,000 gallons of diesel gas equivalencies into that fleet. And obviously, it's only going to continue to grow. Here's our what we kind of did for our biogas, how we distributed it. About 80% of it is actually used to make electricity for us. 13% was going towards our vehicle fuel. And that 7% going to the flare, that's a little embarrassing, but this is kind of a new facility. We did have some equipment that went down that we had to ramp back up, and we had to bring up our gas production super high to run that through its full paces. I mean, it's all honesty, it is what it is, but my first 20 days of November, I went back and looked, and we're only using about 10% of that went to flare. So we really were able to cut back after that. So in summary, this construction kicked off November 2019, right in the beginning of COVID, and COVID played a huge part in complicating things for us and gave us opportunities to problem solve. Construction ended just August 2023. As a matter of fact, I was thinking this morning that it was this time last year when we were seeding the digesters, making them come up, completely brand new digesters. So within the course of the year, we brought those digesters up, and now we're actually able to produce all this gas that we just told you about. Project brought our capacity was restored to 12 million gallons a day again. Now all of our biosolids are diverted from the landfill and being beneficially land applied in the Central Valley. We're bringing in high strength waste, and we're able to digest that, get us more gas. We're seeing the digester gas that we're producing giving us 20% of our electricity for the facility. Right now, we're filling up to 13 garbage trucks. We're looking at expanding it to 35 as soon as those trucks start rolling off the construction line. And one of the other things is we are recovering heat also from our microturbines and using that to heat our digesters. So I want to thank you guys for listening. Jason Fick, if you guys have any questions or want to reach out to me, here's my contact information. Thank you.
Thank you, Jason. And excuse me, we're going to hold questions until all the panelists have gone, and we'll then have questions for each presenter. And with that, I'd like to introduce our next speaker, Kara Morgan. Kara became CalRecycle's Deputy Director of Materials Management and Local Assistance in 2023, after serving as the branch chief of the Local Assistance Branch, providing technical assistance for over 614 jurisdictions and 200 state agencies in California. Ms. Morgan also helped lead CalRecycle's adoption of Senate Bill 1383, legislation into regulations, and other recycling initiatives. Kara now leads the SB 1383 team, providing compliance assistance, implementation tools, and training for jurisdictions and state agencies, as well as school districts, federal facilities, and food recovery organizations. Kara has many years of experience successfully implementing and building the circular economy in California. And she holds a BS in biology from California State University, Sacramento. And with that, it's a pleasure to welcome Kara.
Thanks for having me. Are we good to go or? Hey, it's good to see everybody out here in the audience and in virtual land. How many are in virtual land? How many are listening in? Do we know?
Do it.
Oh, cool. To all of you listening in, it's great to have you here. I'm super excited to be here. I think the bio that Greg read makes me sound way more than I am, but I do feel passionate about what we do and why we do it. And listening to that presentation made me even like, it just, so many bells went off that it's hard to imagine that we've come so far in such a short amount of time through COVID. And now we are producing electricity from our wastewater, from our poop. And I mean, I find that amazing. And maybe I get too excited about this stuff, but I think that is so incredible that we could be so self-reliant and be producing electricity. I'm so excited. And same goes for food waste and other organic waste materials, which is what I'm going to talk about today. So I'm super excited to be here. I'm going to share a high level. Greg asked me to give you a high level of where we're at with SB 1383 statewide implementation. And, you know, I always say that this law was the biggest change in 30 years with how we're managing our waste. And we're making our way through that change. And, you know, making this kind of change takes time, and we're starting to see more and more jurisdictions implementing programs, more facilities coming online, facilities like City of Roseville producing electricity. And so, you know, we're just in this moment, this paradigm shift, which to me is very exciting, where there will come a time, I'm predicting about 5 years from now, where we will all just think about our materials not as waste, but for use in other ways. And I think that's a shift that all of Californians will be going through and are going through now. I'm excited because I'm seeing incredible progress across the state, and I'm here to share that with you today. Also, you know, as you know, CalRecycle is very much focused on building the circular economy in California. Again, really designing materials so that they can be reused or recycled. You know, when we talk about organic waste, there's so many opportunities to create that circularity, as long as we are ensuring that it's not going to the landfill. Next slide. Oh, they're going to do it. I need extra help. So, you know, I think most of you all know that this law was designed to reduce methane, you know, a super pollutant. And by reducing methane, third largest emitter in California are our landfills. And, you know, this is food, paper, other types of organic materials that are actually emitting methane into the environment in a pretty significant way. Conversely, by us recovering that organic waste, turning it into new products, we can have a very fast track to addressing the climate crisis very significantly. I also, you know, want to emphasize that a part of this legislation, which is very unique and different, is the edible food recovery piece. And, you know, it's amazing how many Californians are struggling with having enough food to eat every single day. And yet we have so much good edible food that's there to be recovered. And we're starting to see incredible expansion of the edible food recovery space, many new technologies and systems coming into place. And I remember when we were working through the regulatory process, I had many jurisdictions that, start my timer, that were like, we don't do edible food recovery. We're like recycling and trash. And they're like, this is so foreign to us. Now, when I work and meet with communities, they have extensive new relationships with food recovery organizations and services, you know, businesses that have food to recover, and they're getting that food to hungry people. Millions and millions of meals are now being moved from what previously would have been disposed to people who really can use it. So that's super exciting. Next slide. Just this slide just shows you very briefly the requirements that are placed on local jurisdictions. This law sets state minimum standards for the regulated community. So jurisdictions, businesses, K-12 schools, federal facilities, state agencies, all of California is subject to the requirements to either recycle organic waste or collect that organic waste for edible food, or to prevent the waste from being generated in the first place. And jurisdictions across the state are at different places with implementing the requirements that you see here, but many are really on their way and making their ways. They've developed new infrastructure, new relationships, new agreements, and new contracts. Later, I'll give you some updates on the stats and where jurisdictions are at with implementation. Next slide. I would, as we talk about where jurisdictions are at, right now, we have 616 jurisdictions. These are cities, counties, special districts that provide solid waste collection services. Out of those, we have 75% or 460 jurisdictions that have fully implemented residential collection programs. So that means if they had previously had green waste collection services, they're now allowing residents to put food and maybe food sold paper into that green waste bin. Those jurisdictions that may not have had collection now have collection. That is really a significant number in a short amount of time with COVID, coming out of COVID. It just really incredible progress. We have 12 more jurisdictions that are expected to launch their programs by the end of this year. So that number keeps going up. And then we have 30 more jurisdictions that are expected to launch their residential programs in the first and second quarter of 2024. That is going to bring our total to 502 jurisdictions. So you wonder, what's going on with the remaining little over 100 jurisdictions? So we have the regulations provided some flexibility for jurisdictions to receive waivers. And these waivers are allowed for jurisdictions that are in these really low populated rural areas where it just maybe didn't make sense to implement collection services. So we have about 143 jurisdictions that have some type of waiver from collection services. So we've got that going on. Almost all jurisdictions have reported that they are fully implementing their commercial recycling programs. This, as you know, was a law that started a few years ago prior to 1383, mandatory commercial recycling. And then we see that as a stepping stone to where we're at with 1383. So some of our largest cities in California are in process of fully implementing their mandatory commercial programs. And I expect to see by the end of this year, early next year, that almost all of those large cities will be fully implementing. Now, there's still a ways to go. We still have, a number of businesses that we need to ensure that if they're supposed to have front of the house, recycling containers and signage, that's happening. So jurisdictions will begin their enforcement activities starting in 2024. So that means as they are doing their inspections, if they have a generator, say a commercial business that's out of compliance, they will begin the enforcement process. And that process is progressive enforcement, where it starts off with a notice of violation. So we anticipate, we have a lot of generators that have come on board and started implementing, but there have been, that bell curve, that 20% of kind of reluctant entities. I think with the enforcement action starting in 2024, we expect to see a big increase in the amount of material that's being collected. Also, as I mentioned, jurisdictions across the state are reporting that they have implemented their edible food collection program. Starting in 2024, there's another big milestone for jurisdictions, and that's to collect from the group of businesses that we call Tier 2 commercial edible food generators. These tend to be types of generators that have more prepared types of food. So restaurants, hotels, hospitals, large venues, K-12 school districts, state agencies that have an on-site cafeteria that's of a certain size. So that's going to be a big challenge, but jurisdictions are putting a lot of energy to implementing, gearing up for education, implementing collection services, and really building the food recovery network to take on prepared foods. So I'm really excited about 2024 and the, with enforcement happening, as well as the tier 2 commercial edible food generators. That's going to be another big milestone for jurisdictions. Next slide. So to address some of the challenges that jurisdictions faced with COVID, it did put us behind in our implementation. And so SB 619 was passed to provide some relief for jurisdictions. And basically what it entailed was jurisdictions self-reported that they were out of compliance with the regulations, and they were allowed to be put on what we call corrective action plan. And basically it's a work plan. It outlined the tasks and timelines and basically how they were going to come into compliance. Many of this slide shows you kind of an update of where jurisdictions are at. Many jurisdictions, a number of jurisdictions have already completed their corrective action plans and will be reviewed by our enforcement branch. We have another group that are expected to complete by the end of this year, another group by really first quarter of 2024. So, when I talk about the number of jurisdictions that are implementing, we have jurisdictions kind of different phases of implementation, but this particular SB 619 was a really important tool to allow those jurisdictions to self-report their violations and be placed on this corrective action plan so that they can move into compliance with the regulations. Next slide. One thing also I'll share about that is our local, so we have 2 branches that are really heavily responsible for implementing SB 1383. We have our enforcement branch and we have our local assistance branch. The local assistance staff work with each jurisdiction wherever they are at in implementation. So on that previous slide where I showed the SB 619 jurisdictions, those jurisdictions are receiving a lot of technical assistance with respect to their implementation as they need it. Some don't need as much and some need more. Just to give you some numbers, provide those who are really into the data to share with you where we're at currently with 1383 progress. And I'm really excited about that. The data is also really showing the amount of effort that jurisdictions and Californians are putting into implementation. So just to share with respect to edible food recovery, we had a 20% target in 2025, recovering edible food that would otherwise be disposed. In the first 6 months of 2022, jurisdictions reported 116,000 tons, or almost 117,000 tons of food recovered in the first half. That's about halfway to our target just in 2022. So, and that's not a full year of data. Soon, sometime in December, we will have the full year of data, and I expect that we will either meet our target, our annual target, or surpass it. And that will continue, as I mentioned, starting in 2024, when jurisdictions start implementing programs for those tier 2 commercial edible food generators. That amount of edible food is going to continue to grow and increase. So that's really exciting to see, especially for something that, as I mentioned, jurisdictions were so reluctant because they'd never, ever done anything related to edible food recovery. And now we're seeing across the state just this incredible collaboration and really new approaches to recovering edible food, very creative approaches. So that's super exciting. When we talk about the statewide target of 75% reduction of organic waste, we are on our way. Since, when we started measuring in 2018, we had about 21 million tons of organics that were being disposed. In 2021, that dropped by 2 million. And we expect when we get the 2022 numbers, that's going to continue to decrease. And I say that because 2022, we had a number of jurisdictions that were implementing collection programs and the edible food recovery programs. But again, coming out of COVID, that implementation was a little bit slower. So jurisdictions really, I saw a ramp up towards the latter part of 2022, and then a huge ramp up in 2023. So I'm expecting these disposal numbers are going to continue to go down pretty significantly. On the recovery side of things, really correlates to the amount of disposal. In that 2020, we were recovering about 9.8 million tons. And in 2022, that jumped up to 11.2 million tons that's been diverted through recycling. So exciting to see that, the trend is going in the right direction. Next slide, please. So just to share a little bit about where we're at with infrastructure, we've rapidly been building and expanding the organics recovery infrastructure. City of Roseville being one project, Energia, we're going to hear from another really important project in the state. Jurisdictions have to submit to CalRecycle capacity plans telling us how much they expect or estimate organic waste that needs to be recovered. And then they have to identify what their either existing, new, or expanded capacity will be. In the first report that we received from jurisdictions, across the board, jurisdictions are planning or have enough capacity for their foreseeable future. Some of that is based upon some of the new capacity that's coming online, and the projections are looking good there. Just to give you some numbers, California currently has 206 organics processing facilities in operation, and that doesn't include all that's happening in community composting. We have 166 composting facilities. That doesn't include chip and grind or agricultural material composting. We have 17 in-vessel digestion facilities. We have 21 pending, and that includes co-digestion at wastewater treatment plants. We have 23 biomass facilities. And when we think about our biomass facilities, that's incredibly important to deal with both the urban and agricultural wood waste. And then we have 6 wastewater treatment plants that are already co-digesting food waste in addition to biosolids. And we have, and I think this number has increased more than this, but the last number I received was 120 community composting sites. And those community composting sites are so vitally important in these communities to, really keep the composting local, but the education that happens within that community, and then the opportunity to produce healthy food that can go into some of these communities that really are healthy food deserts. So really important program that's continuing to grow and expand. To let you know, we have 23 new facility permits that CalRecycle issued from January to October 2023. And we have many more facilities coming on in future years. Next slide. So let me tell you a little bit about where we're at with the grant funding. As part of the governor's $15 billion climate package in last year's budget, CalRecycle was provided $270 million in funding to advance our circular economy. And you'll see here a breakdown on the slide. We've been moving really fast to get that money out the door to projects. And just to give you an example, in 2022 for co-digestion projects at wastewater treatment plants, we funded 5 grants with $20 million. With an additional $10 million, we funded another project, and the remaining $5.5 million was awarded to, or will be awarded to, another project that's currently being reviewed under the Organics Infrastructure Grant. So that's really exciting to see an expansion in the wastewater treatment space and co-digestion, because this is existing infrastructure, right? That's already there and cited, and really fits nicely with dealing with important part of our waste stream, which is the food waste. So that's really exciting. Next slide, please. With respect to the funding, the legislature also appropriated funding to local jurisdictions to help them with their 1383 local assistance programs. We call it the local assistance grants. We are ready. Jurisdictions just finished in mid-November applying for approximately almost $90 million. And this funding is used for a variety of purposes by jurisdictions. And they can use this funding to help them with purchasing a truck, for example. They can use it for enforcement, education, so all kinds of different projects that they're doing. So this has been extraordinarily helpful, and why I've seen a huge ramp up, particularly in 2023 for jurisdictions implementation. Next slide, please. So I come to the end, but I want to express that I am extraordinarily excited to see where we're at, only in just such a short amount of time. The collaboration, cooperation, the hard work that Californians are putting into implementing this new law, we have a ways to go, but I really do believe that with continued focus on education, enforcement around the corner by local jurisdictions, we're going to continue to see progress. And I'm excited. I think we potentially will at least get close to our target, if not achieve our target. So thank you so much for having me here today.
Thank you, Kara. And I just have to add that it's been a real pleasure to work with Kara over these last few years as we implement SB 1383. She's been extremely supportive and responsive. So thank you for that. And again, we'll hold questions until the end of the panel. And I'd like to introduce our next speaker, Dr. Janif Scherson. Janif is the Managing Director for the Western U.S. region for Energia. Janif is based in Carlsbad, California, where he leads Energia's projects integrating organics recycling from solid waste with anaerobic digestion and wastewater treatment for the production of renewable power and renewable natural gas. Janif leads Energia's turnkey system offering and supports Energia's design, build, own, operate, and finance arm. He's a licensed professional engineer in California with PhD and master's degrees from Stanford University. With that, welcome, Janif.
Thank you. Thanks so much. Should I sit here?
Yes.
Okay.
If you could, please.
Okay, great. It's truly a pleasure to be here today. Thank you very much for having me. This is the mic. Okay, great. I'm usually pretty vocal, so hopefully everybody hears me well. And welcome to everybody in the virtual world as well. I got to hit next to the maestro here, so I'll have to do that every time. Just hit next. Okay. So next. My name is Janif Scherson. I'm the COO with a company called Energia. I'm based down in Carlsbad, California. And briefly about the company that I represent, we are a global builder and developer of anaerobic digester facilities. In California, we build them around the world. We own a number of plants. And in California, we've built 5 anaerobic digestion facilities that are all converting either sewage sludge and or food waste or both into biogas for power and for pipeline RNG production. Next. Taking a step back, what is the problem that we're trying to solve globally? It is climate change, and specifically it's methane. The world has woken up in the last 2 years, particularly in the wake of COP26, that methane is the singular most threatening culprit to catastrophic climate change to the point of no return than any other greenhouse gas. And the reason being, as we all know, is because its global greenhouse warming potential is nearly 2 orders of magnitude greater than carbon dioxide on a 20-year timeline, which is really what matters. If we're not going to solve this in the next 20 years, then we're all going to cook as a species anyway. So what's the point? So methane is the culprit. The bad thing with methane is it's such a potent greenhouse gas, and 84 times is specifically the magnitude that we're dealing with compared to CO2. The good thing, though, is that it's very easy to mitigate and it has a short lifetime. So if we can eliminate the emissions of methane into the atmosphere, we can have a substantial immediate term impact on avoiding the catastrophic impacts of climate change. So over 100 countries in the world have had made the methane pledge. California, of course, leading the way to methane pledge as well as the 2045 carbon neutrality goal. So like everything here, we in California, we're leading the world with the most aggressive policies and targets. And so this is the calling of our time. Methane is it. And this is why we're all here. Next. Now, if we look at methane specifically, where is it coming from? And broadly speaking, three broad categories. I mean, there's many categories, but three broad categories: oil and gas, waste, and agriculture are sort of the three broad categories. The science on methane has flipped our understanding upside down. Again, in the last two years, we've actually started to measure it, and for the first time with aerial, with a sophisticated technology that basically is flying over point source emissions and just measuring the total flux of methane coming out of point sources. And it's shocking. It's shocking because what we're finding is that landfills, at least in this study by NASA and JPL that flew over the state, is the #1 source of methane emissions. Just I'll let that sink in. Landfills are the #1 source of methane emissions, more than ag, more than oil and gas. In California, 41% of all methane emissions from major point sources come from landfills. And keep in mind, we also have some of the most aggressive landfill methane abatement regulations in the country. So even with landfill covers, even with capture, even with some of the best available control technologies and policy, landfills are still the #1 source of methane emissions. That is shocking. What is also, it's very promising because that's an easy fix. Don't put organics in the landfill. Pretty simple, and that's why this building here, CalRecycle, put this law, 1383. It's a very simple answer. So all we ought to do is enforce 1383 and get the organics out of the landfill. That's the promising side. Okay, well, that's NASA JPL. If you're with CARB, you're saying that's interesting, but that's one snapshot in time. That was one season. We don't have enough data. We need to study this for years. While we're studying it for years to determine what our policy change is going to be, we're cooking and cooking and cooking. Next. Well, we're not the only ones. Studies elsewhere found the same thing. Maryland did the same study and found the exact same results. 37% of the total from the state is from landfills, the #1 source. EPA is on the record stating, and this is from NPR, so we know it's the gold standard. The EPA stating we were off by at least a factor of 2 nationally, at least by a factor of 2, meaning landfills are emitting at least twice as much methane than we're publicly saying on our websites and on our reports, on the record. And just last month in October, EPA released, next. Sorry, next, and then we'll go back to this one. I flipped one more. Okay, let's go back then. I guess that slide got lost. Just last month, EPA, if we can go before one as well. Yeah, right there, thank you. Just last month, EPA released a report, and I think I have a snapshot later in the slide deck, showing how landfills are the #1 source and actually quantified that 61% of all methane is from food waste and 58% is missed. So EPA is on the record saying that the same conclusion as NASA JPL. The #1 source of methane emissions from landfills is food waste because it decays fast and it doesn't get covered quickly. And most of the methane, more than half of the methane that a landfill produces, gets emitted to the atmosphere. That's US national average from EPA just last month. So methane is the calling of our time. If I didn't make that point clear enough, I hope that's the one thing you take away. Now, why is it so important? Well, the beauty with organic waste is that by using this feedstock, by diverting it away from a landfill, we eliminate the fugitive release of methane. So the landfill there you see on the top, those little molecules going up are being spewed into the atmosphere as we speak, millions of tons a year as we speak. If we take that organic waste, we separate it out of trash, we put it into an anaerobic digester, and that digester, the methane it produces, goes into the grid We eliminated that fugitive release of methane. Therefore, next slide, ta-da, we have a carbon negative profile because the feedstock we're using is actually eliminating greenhouse gas emissions, unlike solar, unlike wind. If we take a photon and make electricity, we didn't do anything positive or negative for climate change. The photon didn't do anything for heating the planet. In the case of organic waste, it did. So this is a very key concept to say that renewable natural gas is the only fuel, to my knowledge, that has a carbon negative footprint, meaning we're actually, by producing it, we're sucking carbon out of the sky. We're sequestering carbon by using this fuel. And this is why the policy, if we go next, is supporting the procurement of this fuel, like 1383 has procurement requirements for cities, is because we need to make sure that this fuel has a market to be sold into and actually utilized in vehicles, in heating, in transportation, and in industry and so forth, in order to decarbonize and to offset natural gas. So one of the strategies that Kara alluded to, among many important strategies that California implement, is using existing infrastructure. So the two biggest organic waste streams that cities make, at least, is what you put in the trash and what you flush down the toilet. And so fortunately, these are two pieces of infrastructure that exist today. Material recovery facilities where our trash goes, wastewater treatment plants where our sewage goes. And they both have organic waste that contributes to greenhouse gas emissions and can be leveraged. And so our approach has been, for the last decade, to leverage existing infrastructure by separating organic waste out of trash at transfer stations and bringing it to wastewater plants where there's existing anaerobic digesters. Specifically in California, 156 wastewater plants have anaerobic digesters today. Reports by Corolla and the State Water Board have affirmed that virtually all of the anaerobic digestion capacity that's necessary for 1383's food waste diversion exists today. It's built. It's in your city, in your, probably one of the lowest points of elevation where the sewage flows. And so the solution is just connecting the dots. It's not an enormous greenfield infrastructure change that we need. It's an enormous behavior change and regulatory enforcement change that we need. That's the problem. Next. And so in California, zooming into California specifically, we have a regulatory mandate called 1383. And if you look in your building, you should have a green bin for your organic waste at your residence or at your business. I always like to take a picture at CalRecycle, actually right out here. I always take a picture of the green bin to see how clean it is. I was kind of, yeah, I've got some great photos you'll like, Kara, because our challenge is when people put food waste in the green bin, it's not always clean. So I always take a picture of the green bin. I encourage you to do that. Look inside the green bin today here at CalRecycle, the gold standard for source separation. Just giving CalRecycle a hard time. But just saying that it's difficult, right? We have to separate into green bins. It's not always clean. So we need to separate out the contamination. This is the challenge. But this is what California needs to do. And this practice with 1383 is ensuring that we're getting the organic waste, at least in a separate bin, and a requirement to have it. Now we got to get it into renewable natural gas. Well, markets are emerging. California also did a landmark bill called SB 1440, which requires the investor-owned utilities to procure renewable natural gas with a priority for RNG from landfill diverted food waste under long-term fixed price contracts to the tune of 75 million MMBTUs a year. To give you a sense, that's about 100 anaerobic digester facilities of moderate to large scale to meet that demand, just to give you a sense. And it's a materially larger volume than the entire LCFS program today. So it's a game changer. So we have the building blocks in place. We've got a regulatory requirement to divert feedstock. We've got a regulatory requirement to buy. We need to implement. Next. And then the twin goals, of course, is biosolids, which was actually supposed to be the topic of my talk today and the least interesting of where we are here now, what's in vogue. But biosolids is what our wastewater plants are dealing with. There's a large challenge of ensuring Class A requirements. And so most of our biosolids are Class B, meaning they have pathogens. And so there's a lot of challenges of where we can deposit it. I'll just say that having local, reliable Class A processing infrastructure in California is also a very important driver to have to be able to utilize these organic waste streams as fertilizer and actually use them on California soils, which is the entire intent of 1383 as well. So if we're going to use wastewater treatment plants, we got to make sure that our biosolids can be in a suitable form of quality and regulatory compliance so that we can use them as fertilizers and close the loop. And in fact, catch me aside, that's actually a 10 times bigger impact on climate change by just putting nutrients back on soils instead of synthetic fertilizer. So the soil gets healthy and sucks CO2 out of the sky. That's really where the game changer is. Next. So I'm going to conclude here just giving some illustrations of what some of the infrastructure that we've built in California looks like, to sort of give some hope as what needs to be done. Here's some infrastructure that is all either at wastewater plants or next to wastewater plants. As Kara mentioned, benefits we see is existing siting, existing utilities, existing permits. So a much faster and more capital efficient model to deploy. And so this is a facility in Southern California in the city of Highland. That is a sewage plant taking both food waste and sewage sludge to make electricity and fertilizer as well. And so give you a sense of what this infrastructure looks like. Next. Another facility that we were very honored, I think, was the banner for this conference, or the photo for the invite for this conference. This is a facility in the city of Victorville, California, up in the high desert. It's received quite a bit of recognition. It won the Global Water Intelligence Award of the Year. That's kind of like the Oscars of the wastewater industry in Berlin. Greg would know what I'm talking about there. Very, very prestigious. We were very honored to receive that recognition. And this facility is taking food waste, co-digesting it, putting the gas into the grid. To our knowledge, I think it's the first wastewater plant in the state that is taking RNG to the grid from co-digestion. I guess if you put enough qualifiers, you can be the first of anything. So co-digestion and a pipeline RNG, that's the first, right? So somebody's doing it with sludge only, somebody's doing it with electricity, but not both. And this gas is being sold to Toyota to produce green hydrogen. So this is an example of sort of emerging markets. This hydrogen is used in the port of Long Beach to fuel the Mirai vehicles that come off the ship from Long Beach. So going into the transportation sector for vehicles, supporting our green hydrogen infrastructure deployment. An example of the flexibility of this fuel as well, right? We talked about electricity, CNG vehicles, hydrogen as well. Next. But going back to the problem of food waste here, this is what the trash looks like that we have to separate. These are bins that are both trash bins, the black bin, mixed waste, and then bins that are green bins where source separation happens. And so you can see there's contamination across the board. So this is our biggest challenge with implementing 1383 is how do we get the organic waste out of the trash stream in a clean form? Because we got to clean it before we put it into a digester. We can't put trash into digesters. And so we approach it with a combination of human beings doing a first cut of separation to kind of get the right side of the equation, the right side of the pictures. But then we need machinery to do another step to remove what human beings are imperfect of doing, which is separating to a clean enough standard. So next. So this is what comes in, and this is what we have to deal with. And so the approach here is a system that we have running in Los Angeles. With waste management. Trash is on the floor. We squeeze it with a machine called an Orex. This Orex is like a garlic press. So we squeeze at very high pressure through holes and we extrude the organic fraction out. So the top right photo is the organics that come out from the Orex. So you can see top left to top right is step number one, the squeeze, the garlic squeeze. And then we have another step number two on the bottom where we remove the residual plastic film and grit. So just to say there's kind of three steps in the cycle. Human beings separate step one. Machines then separate step two. Another machine polishes step three. So it's not simple. This requires infrastructure, requires technology, requires both humans and machines to work together. But it's possible, and this is how it works. And so ultimately on the bottom right, we get the feedstock that goes into the digesters. Next. So one of the places this is being done is a facility, the Rialto Bioenergy facility. It's California's largest food waste anaerobic digester. It services Los Angeles, both biosolids and food waste diversion needs. We have Orex machines, the garlic presses, one running for 3 years, another 2 coming online next year. And then another capability to dry and convert to Class A biosolids. So this is the geographic footprint. Waste from LA is collected, separated, and the organic fraction is sent to Rialto. Next. So that's what's tipped on the floor. I just like to show everybody this photo because this is a combination of source separated organics, green bins, and mixed waste black bins. So not every generator signs up for a green bin, this is the challenge with sort of enforcement of 1383. If they don't sign up, we still need to separate the organic waste by the law. You can't get a free pass if you don't have a green bin. So both are processed. If you got a green bin, we process it here. If you don't, we process the black. And that's been the approach for the last 3 years, with the catastrophic delay in enforcement of 1383, at least in Los Angeles. This facility has been running for 3 years. There still isn't material enforcement of an adoption of green bins, of source separation bins by the commercial sector in Los Angeles. So 3 years we've been running, but this is what it looks like. Even when people source separate, this is what it looks like. I need a rush? I'm almost done, okay.
You're good.
And so this is what comes on the floor every single day. And we got to get that, per 1383, either to a compost facility or to a digester. You can't take this to either. This is unacceptable. But this is what reality is. So let's take a next photo, next slide. So that's what the Orex spits out from the mix of source separated green bins and black MSW bins. But you can still see it's still pretty dirty. There's still plastic film and stuff that needs to be separated, but at least we took care of first cut number one. Next. And then the materials then sent to the Rialto facility. Now the story's not so great here. This facility is in bankruptcy. It's been a catastrophic loss of money, and basically because the facility was built 3 years ago, enforcement didn't happen, COVID, then politics, then regulation delays. And so we're still, this facility runs every day, but it's sort of an example of, the call for the need for infrastructure that Kara mentioned. But the other side of the story is a lot of the infrastructure is already out there, but the regulation isn't being enforced sufficiently to support it to survive. And so when the largest facility in the state that's built on time in 2021 for the original requirements in LA and ready for 2022, the original date in 1383, doesn't get the feedstock because the regulations didn't happen, the enforcement didn't happen fast enough, then it's a catastrophic event that is a challenge for the entire industry because it spooks the private sector from investing in future infrastructure when the largest failed. So that's kind of the sad side to the story. So our message is very hopeful. This is the calling of our time. We've got the right pieces in place, but we are at a point now where, in my view, infrastructure is not the bottleneck. Infrastructure is not the bottleneck. What is the biggest threat to success now is just implementation and enforcement of the law. If we don't enforce the law, and then all these facilities will either not be built or fail. Next. And then this is what comes out of the facility, of course, to say that ultimately we're making a clean fertilizer product that can be used in California soils to offset synthetic fertilizers. Next. Okay, thank you very much for the time.
Thank you, Yara.
Yeah.
Thank you, and thank you all the panelists. Excuse me. With that, we'd like to open it up to questions, first in the room and then online as well. There's a question right there, Dan. Here, I can.
You want to do that?
Sure. Want to just introduce yourself too?
Hi, I'm Julie Berry. I'm from Bioenergy DevCo. I actually have several questions, if that's okay. First for Kevin, I was wondering what the response was when you approached the local restaurants and other industries for their fog, if they were ready to go for it. For Jason, I'm sorry. Jason Flick.
So we went through, we were looking at doing a co-op like within the city, but the ordinances and the stuff that we'd have to do was pretty onerous. So we partnered with SAC Rendering, who already had the routes and stuff set up. And then even with that works for us, especially because we're going for RINs and LCFS, and that reporting requirements of how we bring that in and where it comes from, just having one person take care of all that for us kind of is helping us out.
But they were open to providing the fog and getting rid of their grease trap.
Yeah.
Thank you. For Kara, so I know that a lot of the legislative and grant money that you had mentioned are being expended. They're expended, and mainly 2023 legislative type money. With the tier 2 requirements coming into play in 2024, do you have line of sight into whether there might be more money to help that?
I don't know the future, but I do know that this last round, which is like $90-ish million for local jurisdictions, is going to be getting to them in about the April timeframe. So, I am particularly, hopeful. All of the local assistance team members reached out to their jurisdictions, really emphasizing the need to utilize this funding, at least a portion of it, to expand their edible food infrastructure. So we put a lot of emphasis to the jurisdictions on that, because I don't know what the future will be, but they have a significant amount of funding right now that we expect and want them to utilize a big portion of it, to tackle their tier 2 and expand that food recovery infrastructure. So I haven't seen the application requests that have come in, but it was a big push on our part to have jurisdictions think about including that piece. So yeah.
Okay, and I've noticed that for a number of the large in-vessel compost facilities, there have been enforcement issues, or the facilities have closed over the last 5-10 years as far as the permitted ones. And I was wondering if your experience with that is similar to what the gentleman from Energia was saying, was that a lot of it comes down to regulation enforcement.
Yes and no. I think it comes down to feedstock security, right? Guaranteed feedstock for these facilities to pencil out. It requires that stream of feedstock coming in, those tipping fees coming in, and that assurance. And I think that's been the biggest hurdle for new projects, is securing, those long-term, and it's got to be long-term, right? Feedstock contracts. So that's one piece of it. I think the second piece, Yaniv is absolutely right, the enforcement aspect. And that's why I'm really excited about 2024. Some may feel a lot of trepidation, but with the fact that jurisdictions are now required to enforce on generators not complying, that's going to be a big push. Now, there's still going to be some generators that are like, fine, penalize me, whatever, right? And so we'll have to assess that as we move forward of, what kind of number of generators are we talking about? But I really do believe that a large number of generators that have not stepped up and participated, now that jurisdictions have enforcement that has to happen, and some jurisdictions have started their enforcement early, that's going to start. And we talked about City of LA, City of LA is primed with their implementation. City Council recently directed staff to make some significant changes, including renegotiating the agreements with the commercial franchise haulers. They are really moving into enforcement in the coming year on generators that are not complying. So to me, that yes, would I wish it was earlier? Yes, but again, I do think COVID was a huge challenge for jurisdictions, certainly City of LA. But I am extraordinarily pleased. The numbers there are continuing to increase, but I really feel like after these contracts are renegotiated, haulers being required to provide that mandatory collection on the green container service is going to start to, move that needle significantly. So yeah, I agree with Yaniv. I think the enforcement piece is really critical, but we couldn't do that right at the outset. We had to start a little bit more gently, right, with education and encouraging those and getting the collection systems up. And now we've got those collection systems in place. And so I think we're in a good space. I'm very excited about the coming year and seeing what's happening across the state.
And then just one last question for Yaniv. I noticed that it's like less than 0.1% or something like that of contamination in the soil conditioner product. And I was wondering if you guys test for PFAS?
Yeah, there's a,
Oh, I think
it's not on. How about now? Yeah, so there's a California compost standard that has to be met, which is the 0.2% dry matter. So that's met. PFAS is not currently regulated or required. We do have a partially built pyrolysis units at the Rialto facility that your company knows very well about because they're involved. So you may not know, but they are. But they and so that is the answer to PFAS. So should we be able to complete that project with the future of Rialto, whatever that might be next year, then the plan would be to dry it and then pyrolyze. So we do destroy PFAS, we make biochar, but it's currently not a regulated content.
And I would just add a couple of things. One, on the funding piece, excuse me, on the federal level, the Inflation Reduction Act offers an awful lot of incentive and financial capability. So that's something, to be aware of. And on PFAS, in California, at least, we did the investigative order that the State Water Board issued back in 2020. And so influent, effluent, and biosolids have been monitored. The water boards have said that they have found no cause for concern from wastewater yet. So we'll have to see what happens ultimately in regulations, but we don't expect something at this point. And the other thing I would say, just in answer to Jan saying that, on the benefits of Class A, yes, there are some benefits to Class A, but we also strongly believe in Class B being a very vital soil conditioner and fertilizer, and offsets in organic fertilizer as well. So I think A and B in the state are certainly good. Further questions, Chuck?
Real quickly, this is Chuck White with Manat, Phelps and Phillips. You'll be hearing from me later today. But in the meantime, I have two questions, one for Kara, and that is, could you give us a little update on where the Little Hoover Commission issue is now with respect to wanting to stop 1383 and put it on hold? Most of industry kind of think that's a bad idea. I think CalRecycle thinks it's a bad idea, but I didn't hear anything you mentioned I came in a little late, so I didn't hear your first part, but anything you can do, just give us what are the plans for the future on dealing with that issue?
Well, the plans for the future are moving full steam ahead, right? I mean, that's my perspective. I think I appreciate where the commission came at this. I think that some of the stakeholders that spoke, some of the rural jurisdictions are, really concerned about their ability. But, my take for the rural jurisdictions is while their rural waiver does end in, the end of 2026, they then can apply for low population waiver, right? And so I think a lot of it is, I really feel like in 2022, there was a lot of, how do I put it? Like, I feel like a big part of my job has been keeping people from going over the cliff, and the fear factor, right? I mean, I really feel like early on, people were so concerned about the procurement requirements, which was a big part of the commission's findings. And yet I have jurisdictions across the state who are implementing contracts, agreements, for example, with Energia to procure the electricity or RNG attributes. Just an example. Jurisdictions are now moving into solution mode and really finding that they can do this. It can be done. And yeah, is it changing? I mentioned earlier, you might have missed that, Chuck, where I was talking about jurisdictions when they were first faced with the edible food recovery requirements. They were like, I don't even know what this is. And, just that sense of trepidation, and someone whose job has been always about managing solid waste, right? They're like, I don't even know what you mean by edible food recovery. And yet we're so far beyond that now. Jurisdictions are implementing programs. They've built these collaborative relationships, and they've entered into a space that, wasn't their place before. And so I feel as if these last 2 years have been a lot of, getting over trepidation, really moving forward, finding solutions, developing collaborative relationships, and thinking about how we manage our waste in a different way. And that I think initially, I think with the commissioner's report and the stakeholders that testified was a lot of just that fear and trepidation and the significant change that is in front of us. And what I am seeing now, jurisdictions are moving forward with their implementation, industry is moving forward, and nonprofits are filling that gap. And I think that's where we need to be. Now, what the legislature chooses to do with the commission's report and any changes we see in statute this year, I don't know what that looks like, but I think that we are far enough into this with implementation. There is no turning back, is my perspective. And we have to. I mean, you know, if we put a pause, climate is not pausing. What we're seeing with existential threats with climate change, that's not pausing. And so we have to continue forward with dealing with methane. To Yaniv's point, this is a short-lived climate pollutant. It is something that if we address it now, we can be on a fast track to saving our planet. And I think that's what we need to be focused on. And as stakeholders combined and working with our, you know, our legislatures, we have to continue to put forward. Now, maybe there are some tweaks that we can make along the line with procurement. For example, AB 1985 gave jurisdictions, you know, a stepping stone to those procurement requirements. I think that was good relief for jurisdictions. So I think maybe things like that, I think, make a lot of sense. But we're definitely on our way, and I see no turning back, no pause.
Great, thank you. One more quick question. I can't, yeah. One for Yaniv, on the, your project, I guess, I can't remember where it was, but you have the Orex that produces this material that's much cleaner and more suitable for composting. Is that material still a waste, or is that material a product that can be used? The good news, I guess, about compost or digestion, that's a form of composting. So you can, the law allows you to put that kind of material directly into, even if it was a waste, it would still be considered allowable. But other kinds of technologies like pyrolysis and gasification are of concern. And I was wondering, have you given any thought to how you're going to operate that pyrolysis unit to take that material? Is it still going to be a waste going into that pyrolysis unit, or will it be a feedstock?
Well, you know the old age saying, one man's trash is another man's treasure. So
I know it well.
I look at trash cans and I don't see waste, I see resources. So my answer is no, it's not a waste. It's these are all energy and nutrient resources, and most importantly, a carbon resource. Yeah, it's a product. So there's you know, I talked about multiple facilities. The concept is to take organic wastes, whether it be what's in the trash can, you know, we're going to say food waste for colloquial terms, but there's much more than just food and organic waste and trash. And then sewage sludge, you know, which I was using the term biosolids. That's the industry term. And so these are two principal organic waste streams that come from, you know, cities and wastewater plants. And so both can go through digestion to make biogas, and both have the option when they come out to be as a Class B or a Class A fertilizer product, or both have the option to upcycle to another product called biochar.
Just to make sure I understand, so you're planning on operating the pyrolysis unit, that material going into the pyrolysis unit is no longer a waste, it's a material for a feedstock for producing energy.
Yeah, pyrolysis doesn't produce energy, it's the digester that does.
Yeah, right.
So what comes out of the digester is called digestate. The solids are called biosolids. So what comes out of a digester are biosolids. Those are the solids that didn't convert to gas. And that is a fertilizer. That's a product by itself. Now we can convert it to another form called biochar. Yep. Okay.
Okay, so we do have some questions from online. Do we have any other questions in the audience? Because we're about 5 minutes out
of time. So why don't you want to read one from online?
Yeah. All right. So this question was addressed to Dr. Scherson. What is the gold standard for measuring point sources of methane emissions? And did the studies from NASA and JPL that measured methane emissions remotely by satellite with other local methods, were the emissions verified by another method?
Feel so distinguished, Dr. Scherson. I usually go by Yaniv, but thank you for the question. The gold standard is a big debate right now. What is the standard of measure? And it's a very big policy controversy. So if you're interested in this topic, I would encourage you to engage with CARB directly. The gold standard, there's three sort of bodies of work. One is the 90s, which was modeling. And that's where our current science is based on. That's CalRecycle and CARB's official policy on how much landfills capture is from 1997. So that's first body of work. And that was, we're modeling it. We think landfills capture 75%, but if you can measure it directly, do it. That's 97, and that's where we are today. We're on 1997 body. Next body is point source, where we put measurements on top of the surface on a grid spacing, and we see how much methane is coming in that source. If there's a giant plume spewing methane between the two cells, we don't capture it. We don't know. So it's a grid spacing. And landfills have an open face. So waste, before it's actually covered, the time passes when it's uncovered. We don't measure that, gets completely missed on that level. The third is what NASA and JPL did, and that's where they flew drones, not satellites, but drones over point source emissions and have spectrometers equipment that measures total flux from an area. Now there's limitations. There has to be a minimum threshold of methane produced to meet a detectable limit. So it won't measure diffuse limits, but there's the minimum threshold, and there has to be a defined surface area like the boundaries of a landfill, but it's currently the best we've got as far as state of the art in measurement, because it's quantifying within a defined control volume the total flux coming out from an area, and that's called point source measurement with drones. So today we have drones. Now, the big question, I think, more than the state of the art is, what are the policymakers going to do? Are we going to stay in the 90s? Or are we going to get into the 21st century with drones? And is that enough? And that's the biggest point of contention now.
All right, thanks for that. And then one other question, don't know who this is. I think anyone can answer on the panel. Have you ever considered working with Taylor Farms and recycling their organic waste that they dispose of at their packaging plants? Apparently they're composting 1 million pounds per week per packaging plant. Is anyone familiar with Taylor Farms? All right, yeah. I don't think anyone knows that specific facility or business, but thanks for the question. Any other questions from the audience? All right, I think we can.
I think maybe we ought to wrap it up. Please join me in giving our panel another round of applause. Thank you all very much. And with that, we have a break until 10:45. Thank you.
And for anyone in the room, I didn't have a chance to give emergency exit notifications, but you obviously know the way out, the two back doors, down the stairs, meet and Cesar Chavez parking in the park for fire. There's also exits behind the podium here, and all the food, help yourselves. And I think there's a compost bin somewhere. I have not sought it out, but it sounds like it's close by. So please use that, because everything should be compostable up there. Thank you.
I'm sorry to miss you in the afternoon.
Yeah, but I'm gonna go up and get it.
Okay.
Likewise.
Wonderful.
I want to go get that.
Cool. I appreciate that.
Yeah.
Will either of you be available at the end of the day for the final Q&A?
I
Discussion.
don't know.
I'm trying to be online.
Yeah, what time are we doing that?
4 to 4:45?
Yeah. 4 to 4:45.
I have a conflicting meeting actually upstairs at 4.
Oh, no.
So I don't know, yeah.
Yeah, but I'll make sure I'm here.
That'd be fantastic.
Mhm. Yeah,
Thanks,
yeah,
thanks, Kara.
yeah. I have a train
Kara's
ride to Oakland.
She's far more important for the compost producers. We're just a little guy.
Important
Yeah.
guy.
Soon to grow into bigger guys.
Yeah,
Yeah.
the guys and gals, yeah. This is the next
Yeah,
20 years.
great job. Both
Yeah.
of you, thank you.
Well, it's fun to get the gang together again here.
Yeah,
We've been at it for a long time. And things are starting, slowly starting to happen now,
They really are starting. I'm super excited about hydrogen as well.
Yes, well, that $1.2 billion hub.
Well,
California.
we need to know that it works on wastewater biogas. That's the big
Yeah.
question.
Yeah.
I
Yeah.
mean, we need some demonstration projects, but great news on Sutter County.
I'm
Thank
glad.
you. That was
You're
great.
welcome.
That
Glad.
was great.
Yeah, I'm glad. I do have Carla following up with them to make sure.
That, I got that from Yuba City and they said that's what's going out for public comment.
Yeah.
So they accepted all of my comments, which is great. Yeah. We'll see. I think Yuba City helped a lot too, just because they're in the county and
We're
they're
not, right now it's on hold.
landfilling now.
Yeah.
No, it's a financial.
That's great.
Huge.
Yeah.
Well, and I feel like.
No, the facility went into bankruptcy. So right now it's all funding stopped.
Yes,
Okay,
yes.
Sutter just did it. Why
Right,
can't we do it
absolutely,
here? So I think
absolutely.
that's huge. So,
Yeah.
hi, how are you? Yeah, nice to.
Have you
see
not
in
ever met in
person.
person?
We're not dealing with it.
Oh, I think just on the, the TV. Thank you.
Yeah, so we're not.
Municipal solid waste.
Yeah, municipal solid waste doesn't touch it.
We were using sewage.
Oh, really? Good.
It's not happening. Yeah. Yeah, of course. Thank you. Thank
Well,
you.
once Sutter's done, then we can go to Stanislaus.
I think so.
Yeah.
I
Yeah.
think so. So I'm very
Absolutely.
excited. Uh-huh.
Yeah.
Yeah. Well, I
They
did.
don't want to do anything, right?
I think there's a education component that needs to be followed through.
Uh-huh.
I think the Farm Bureau.
Yeah, well, there's a lot of
I do think if
capacity
Yeah.
to be which nutrient, like, we need to know more like which nutrient, but generally speaking,
Yeah.
each facility has a bottleneck at some point, nutrients,
Uh-huh.
hydraulic capacity, equipment. So what we do is we
Well, I'll peek and look at what the latest status is that I have on Stanislaus, but
and what that means in nutrients is it could be there's too much nitrogen.
yeah, but we've been doing some things behind the scenes.
Okay,
So
thank you,
I'll
Scott.
check and see what.
That's needed to just retrofit
How long does it take for the process to retrofit a facility?
1 year.
1 year?
Yeah.
Huh, interesting. You told me 5.
Yeah, well, we do it in a year.
Okay.
Yeah.
That's good to know. I don't.
the usual. Ready to share, and then once you go to the presentation, and we'll make sure to spotlight this computer. Actually, no, we won't do that. But yeah, we'll make sure it's on. All right.
If people are ready, even if you're not ready, we'll get started. So if you're in the room, please take your seat. And if you're dialing in, you're probably already in your seat. So let's get going. The next session is moderated by Chuck White. Chuck is a senior advisor with Manette, Phelps, and Phillips. And he's also a member of our planning committee. And so, and been many years in the industry. I'm not going to read your whole. So we really appreciate your engagement with us here, and I'll pass it over to you.
That's great. I think I've got it.
Okay.
There we go. Thanks, Dan. I hope those of you watching or here don't mind me wearing my Michigan jacket here. It's been a pretty good week. I was up in Oregon watching the game with some friends, and it was exciting. But lo and behold, we may be playing Oregon and the Rose Bowl if everything works out right. So we'll be seeing what's going on. I really appreciate the opportunity to get up and moderate this panel. I'm not going to speak too much because I am no longer an expert anymore, if I ever was. But we got 4 people that I think can really contribute to. My concern is, can we ever produce low carbon energy from waste? And I know we're doing it through anaerobic digestion. We're talking about it, but are we really on the route to get that accomplished? I'm interested to hear what the panelists have to say about the future of waste to energy. It's always been kind of a negative thing, pyrolysis and gasification, those of you may have heard my question earlier, it's kind of viewed upon negatively by the environmental crowd, and for probably good reasons. But I'm hoping that at some point in time we can come up with a way to efficiently and effectively convert waste into renewable low carbon energy. My 2 concerns with respect to that issue is methane, which was talked about earlier in the presentation. And every time you deal with organic waste, you're having to deal with the problem of methane. And the Environmental Defense Fund has come up with a proposal that they're pushing that methane ought to be kept to 0.2% of the total methane delivered would be fugitive. 0.2% would be fugitive emissions based upon your total delivery. And that it seems like it's a good, a possible good target. You're not going to get rid of methane altogether, but get it down to the point where it's no longer contributing to climate change to the extent that it is, whether it's 20 times or 85 times more potent than carbon dioxide. It's clearly a matter of concern. And the second issue besides methane is, can we produce energy from organic waste? And so I've got 4 people. I'm going to start off with Mr. Sam Wade, whom I've known for quite a while, who is the Director of Public Policy for the Coalition of Renewable Natural Gas. And I was around when the RNGC first got started by Escudero and gang. And it's been grown into a very effective organization for advocating for renewable natural gas. Sam started out with started off with a variety of places, but before RNGC, he was at CARB, a very knowledgeable person working on various greenhouse gas issues, and particularly the low carbon fuel standard, cap and trade, and other types of things as well. So Sam is a reformed mechanical engineer, as am I, from the University of Michigan, him from California institutions, but he went further on to Columbia University, I believe. So it was quite a man of well-educated gentleman, and he is here to give us a sense of low carbon renewable energy from organic waste. Thank you.
Thanks very much. I really appreciate the opportunity to be with you guys today. And yep, I finished up the engineering degree, and then I decided I would try a bioenergy startup for a little bit. And that was so challenging. I was like, I'm going to go get a public policy degree. So go work in government and affiliated with government. And that has been fantastic. And it's been centered around climate for almost my whole career. So it's really fantastic to be back in the car building as well. Just a little bit more about who the RNG Coalition is. We're a national trade association for the industry. We were started in California, but we've expanded and we cover activities federally in the US and Canada. We have almost 400 members now, and we represent 98% of the pipeline interconnected projects in North America. So you probably already heard a little bit about this today, but we believe the primary goal of our industry really is to capture methane from organic waste sources and put it to productive use. The feedstocks that we target are currently creating environmental harms or damages, and after you convert them to renewable natural gas, you help solve many of those problems. These concepts are not new. They've been supported by US EPA and California agencies for more than 25 years. But I think what's changing is the scale at which the industry is becoming a real significant player in the renewable fuel space. And that really represents an evolution based on smart public policy and sort of proven technology deployment based on government frameworks. So RNG today comes primarily from municipal solid waste and landfill gas projects, but there's also a growing component that's coming from agricultural waste, most notably dairy and swine manure, and then a good amount coming from wastewater plants, and of course, source separated organics or food waste, which is probably the biggest area of growth potential, taking the organics out of the landfill and putting them into dedicated AD and composting facilities, as this state here in California has been at the forefront of for quite some time. Looking across the US and Canada, there are enabling policies really almost everywhere. And that has led to a significant growth in the production of renewable gas. As I said, we're still not large compared to the use of fossil gas, unfortunately. We are about 1% of total gas demand is served by renewable gases in North America today. So still a long way to go. And of course, there is no conflict between programs to reduce demand for gas and programs to increase renewable supply. Sometimes I feel like that myth is prevalent, and there is no conflict. You can do both at the same time, and you probably have to reach climate goals dictated by the IPCC and others. Looking at how RNG and biogas needs to grow, I mentioned the US, it's about 1% of gas demand today, but there are other countries out there across the world that are doing much better. Denmark, for example, is up to 40% of their gas grid is served by renewable gas. And the IEA projects that RNG globally must increase 27x from 2021 levels by 2050 in order to meet aggressive decarbonization goals. How are we going to do that? We think that some of the most effective tools are already fully demonstrated and just need to be adopted and used by more jurisdictions. The one that we like the best is really a renewable gas standard that's analogous to the renewable portfolio standards that have worked so well on the power side. Basically what this is the utilities or other gas suppliers are required to procure a share of their gas as renewable. And that's very similar to how the RPS has helped make so much renewable power prevalent here in California. Same concept can be applied on the gas side, and it should be. In 2018, we helped pass a law, SB 1440 in California, that basically set up a framework for that. And at the Public Utilities Commission, they went through a process to set a target. The goal within that framework, the California Renewable Gas Standard, is basically trying to achieve a 12% blend in the core gas system by 2030. The other West Coast states have followed to some extent. Oregon has an RGS as well through their Senate Bill 98. It's been very effective. They're targeting 20% by 2030 and 35% by 2035. BC in Canada has a similar framework. And then across the country, you see some frameworks that are analogous and some that are a little bit more innovative and more similar to sort of frameworks that evolve any type of way of decarbonizing gas demand, and they call those clean heat standards. So we're supportive of those as well. If anything you can do to help promote RNG or other methods to decarbonize gas demand, we think is a positive thing. So frameworks that are emerging, for example, in Vermont, are exciting to us, and we're looking forward to seeing how those play out with respect to motivating demand for RNG. Digging a little bit more into the California system, one thing we'd like to compliment the state on is this year there was another piece of legislation, Assembly Bill 678 from Alvarez, which extended the 1440 framework to non-utility gas suppliers and lets basically core transport agencies participate in this and have a real agency to go out and buy RNG for their customers as well. The goals are aggressive in this framework. Basically current supply in North America is about 80 BCF or so of renewable gas. It's probably a little higher than that. These numbers are dated, but the demand that would be created by California, Oregon, and British Columbia's BCSs actually exceeds current supply, which is really exciting, but also means that we're going to have a lot of growth in the next few years. Another big driver that we think is really important to continue and to expand to other states is low carbon fuel standards or clean fuel standards on the transportation fuel side of things. We've seen that again, mostly on the West Coast, but also across the country in Canada. And that's been fantastic because what these programs do is they motivate all clean fuels and they score the fuels based on the life cycle carbon intensity of each of the various types of low carbon fuels. Renewable natural gases tend to score extremely well in those types of frameworks because they do reduce so much methane that they receive recognition for that. And so some of the best carbon intensity scores in these transportation fuel programs are renewable natural gas related pathways. And this framework stacks well on top of the federal RFS and other key drivers that have been important to the industry historically, which I'll get into shortly here. So the RFS, has been around for a while and has been a key driver of RNG development, as many of you probably know. The big change recently is that the EPA finalized their SET rule, which was to, for the first time, set multi-year targets in the D3 space, which is where most RNG plays. They're targeting a pretty aggressive and exciting goal of about 1,380 ethanol gallon equivalents by 2025. And that should be enough to saturate almost all natural gas vehicle demand in the country with RNG, which is a great goal, we believe. I think that the EPA is also looking at expanding the framework beyond natural gas vehicles. Folks have probably heard a lot about the idea of eRINs or RINs given for biogas to power to electric vehicles. We're supportive of that. We're also supportive of pathways that involve transitioning RNG to become hydrogen or to become an input to making liquid fuels. All those things we believe are important to do, and that EPA could sort of double down on that moving forward. There's also key new tax credits that have been extremely helpful to the industry under the Inflation Reduction Act. Recently, we had some less than favorable guidance come out under the ITC framework for biogas property, converting it into renewable natural gas. It seems like the Treasury has sort of come out with a more limited framework than we'd like to see for what might be eligible for the tax credit. But there's also the 45V hydrogen tax credits, the alternative fuel tax credit, 45Z, which is a tech neutral long-term framework. So the IRA had a lot of really exciting things in it for the industry. I forgot to also mention the CCS component of things. Many of our projects are looking at their CO2 stream as a potential revenue source as well, and trying to figure out how to utilize their CO2 stream or to sequester it to improve their carbon intensity performance and get to maybe carbon negative outcomes, which is of course possible with bioenergy pathways and not seen very many other places. So the IRA has helped enable all of that. The industry is very excited about it. We still have some challenges to work through with Treasury around the specifics that we're engaged in currently. I'd also like to talk a little bit about how important a framework for tracking RNG effectively will be moving forward. You see this already in Europe where they have longstanding gas registries to track renewable gases. We're trying to help get the US and Canada to one uniform framework as well to track injection across all the projects, ensure there's no double counting, ensure that claims can be made across all these government programs in the same framework. We think as you move from the sort of hundreds, we have about 300 or so projects in the US right now, pipeline injected RNG projects. If we get into the thousands or maybe eventually tens of thousands, we're going to need a system that can track it all effectively. So we've been working with MRETS, which is a tracking system for renewable power that's actually utilized for California's RPS and all the Western RPSs, as well as many of the Midwestern systems. And we're trying to develop a renewable thermal tracking system that can be utilized across all government programs and in the voluntary market for RNG. So that is sort of complemented on the voluntary side by the Green E sustainability certification that says that the RNG was produced in a sustainable fashion. And that pairs well with the MRET system, which tracks volumes and how much was injected and withdrawn, and allows you to commercially transact RNG really well. So these are like really basic building blocks that the industry has put a lot of time into trying to get right and to try and expand, as I said, across North America in an effective way. There's even a debate between us and Europe now. Is this system strong enough to allow it to be the major way you could declare RNG volumes moved into Europe, sometimes in the form of methanol or other energy carriers? But could there be international trade in renewable gases? We think there could be, and we think that it's really important to get a framework set up that allows you to do that across everything. So, so just to kind of conclude with sort of some thoughts about the evolving role of renewable gas, and Chuck framed it as, will there be a role for renewable energy from biomass? I think there always will be. We just have to be very sophisticated about how we approach it. In the near term, the focus is on reducing methane emissions. That's why AD has been the primary technology that's been utilized. It handles wet feedstock that otherwise would probably break down and produce methane in many cases. So we want to build those facilities as quickly as possible, reduce the short-lived climate pollutant, adopt the policies that I spoke about as the key drivers of making that commercially viable. And then the midterm, we believe you should prioritize RNG use in hard to decarbonize sectors, especially if electrification and other tools are as effective as many of the environmental proponents believe that they will be. And then as you sort of shift the RNG use over time, having it be pipeline interconnected is critical, right? This isn't about sort of building the end demand right next to the RNG supply. That's infeasible in many situations. You have to have a good system for transporting it and moving it to the end uses that are hard to decarbonize using other solutions. And in fact, as you do that, perhaps at some point, the energy carrier switches from being methane as the primary molecule to being hydrogen or to being electricity, right? And we believe that's more of a long-term switch, but obviously with the hydrogen hub deployment occurring and California receiving a hub, you're going to get a chance to test a lot of that very quickly here. And that is a long-term home for renewable natural gas molecules, is turning it into hydrogen. And when you turn it into hydrogen, of course, you can capture the CO2 and sequester it, get carbon negative outcomes, as I said. And that means you can probably bring in a lot of other biological wastes as well, right? You're not just dealing with the wet waste anymore at that point. You're getting into pyrolysis or gasification of solid biomass, and you're turning it into hydrogen or into liquids, right? So those opportunities are there. When the hydrogen transport infrastructure develops, you can couple it with CCS and get really good outcomes regardless of your feedstock. So we like to look at it more as organic waste to X, right? It's not, it has to all go into CNG vehicles or it has to all go into power. Really, it needs to be a flexible framework that allows us to switch the resource over time to the sector that needs it the most. And we should not be at this stage of the game closing off any opportunity. In fact, the most important thing, as I said, in the near term is just to go after the methane and prevent it from going in the atmosphere, prevent this gas from being wasted while we're still pulling fossil gas out of the ground, right? Those two things, you should think about as a near-term emphasis. And then the long run, we'll find out which sectors are the hardest to serve with things that are, not gaseous molecules, right? So just like everyone to think more about a circular economy and how really what the organic waste opportunity presents is a chance to recycle waste in a smart way. And then more broadly, how can we link RNG production to other sustainability goals, and how can the deployment of an RNG facility be used to facilitate broader change? And then, of course, achieving carbon neutrality or carbon negativity and going after sort of better than carbon neutral performance where possible and maximizing methane reductions as you do so. And then finally, having a good accounting standard that lets you do all that. So here's my contact info. I really appreciate the time today and happy to talk to anybody about these issues moving forward. Thanks, Chuck.
Great. Thank you, Sam. We're going to do a little bit different than the last panel. I'm going to try to take questions now after each speaker, but if we still have time at the end, we can do another wrap-up question and answer session. So if anybody has any questions for Sam, raise your hand, or we can see if there's anybody online that would like to. And Evan Edgar seems to have one. We need to get a microphone to Evan.
Your California Compost Coalition, is it working?
That's on now.
Okay, here we go. Evan Edgar, Edgar Associate, California Compost Coalition. I represent the solid waste sector, and we've been decarbonizing for 20 years, and we're co-located. So when we build an RNG plant, we have a captive waste stream because of the franchise, and we have a captive fleet. We have a fleet, and a lot of times we don't have a pipeline. So what I heard today was that you make RNG for hard to decarbonize communities, like CARB is promoting that too. But I hope RNG Coalition would support that when you're co-located and you have a tethered fleet, that we can put it right back in trucks without going to the PUC pipeline. I'm community scale, so we have a harmonic fit that we make enough gas where our trucks are our storage capacity and it fits our demand and supply. So I want to make sure that I'm working at CARB to support that. But what we saw in Advanced Clean Fleet World with the transition to ZEVs is they want to destroy a circular economy, because right now we have a circular economy, carbon negative, we make organic compost, we're doing it. And we're told by CARB it's not good enough. And they said, get rid of that, dig up the Congo for ZEV batteries and have a linear global economy that's injustice to get rid of our RNG circular economy today. So I've been working hard at CARB for a carve out. So I hope RNG Coalition would support a carve out for the solid waste sector who's doing it, who don't have a pipeline, that we have a truck fleet to put the RNG back in the truck. And I want to support that for another generation until hydrogen comes into play. But I didn't hear that from you, Sam, and I was hoping you would support me on that.
I will support you on that. And I think CNG end uses are an important application today. It's obviously been the main way we've grown the industry and captured all the methane thus far. So I believe it's still difficult to decarbonize heavy duty trucking. I don't think that is an easy thing to electrify, honestly. I do think that the goals that we have as a state are appropriate, though. I think we should try hard to, maximize the use of ZEV vehicles for clean air and other reasons. But natural gas vehicles have great air quality performance too, relative to diesel. So I think petroleum diesel really is the main problem that we're trying to address with programs like the low carbon fuel standard, and we've forgotten that a little bit, right? So thanks.
Thank you.
Ever a spokesman for the solid waste industry, aren't you, Evan? Good. Anybody else have a question? I've got one. There's this anti-natural gas movement going around through, I think Berkeley has prohibited new development of natural gas infrastructure. Is that good or bad for renewable natural gas? So my feeling was that it's kind of bad. We got to be able to preserve the structure we have now for distribution of renewable natural gas. But I'm curious about where you are on that. I've never heard you guys oppose Berkeley's city council thing. So I thought I'd just get a sense of where you are on that.
Thanks. Yeah, it's a tough question. And I think it's a very political question. It's people framing it as if it was an either or choice, right? Either you can develop renewable gas, you don't have to change the gas system at all, or you destroy the gas system immediately and it disappears, right? And neither of those things are practical. The reality is You can attempt to reduce demand for gas over time through efficiency and electrification and other tools. At the same time, you increase renewable supply, and those things are not going to be in conflict for another 20 to 30 years. So that's why we don't go aggressively against cities who want to, attempt to explore issues like this. We think electrification of new buildings sometimes makes financial sense and is therefore fine. Retrofitting existing buildings is extremely challenging and cannot be done, with a snap of the finger. So there will be a role, even in buildings, for renewable gaseous fuels, and we're happy to serve that demand to the extent it exists in the long run.
Great. Thank you, Sam. Any other questions from the room or online? Well, I got one final question then for Sam. Renewable natural gas is pretty much dependent on landfills and anaerobic digestion now, as I understand it. Do you see other technologies coming into play on making methane or waste material into a viable fuel? Is that gasification, pyrolysis? What do you think is going to happen there?
Yeah, we're supportive, as I said, of getting into the more woody feedstocks and going after gasification and pyrolysis, which are both relatively proven technologies, but not inexpensive. So you need to have good greenhouse gas performance. As you do that, you need to have strong criteria pollutant performance, which has been an area of focus. Like, I think a lot of the NGO community does not understand the difference between gasification, pyrolysis, and incineration, right? And that has been a huge challenge when you're talking about those waste streams. And of course, anytime you touch solid forest biomass residues or whatever you want to call them, it becomes highly controversial. So, those are the challenges I see with those feedstocks, but we're supportive of those feedstocks. We're also supportive of, boosting biogas yields at RNG facilities by matching it to electrolytic hydrogen or other opportunities to create synthetic gases. We believe all those can be done well, but you have to hold yourself accountable based on your GHG performance of those projects.
And as you mentioned, the solid waste is kind of discouraged from gasification and pyrolysis in California by state law. Do we need to change state law, do you think? Or is that a debate yet to have at some point in time?
I think it's a debate yet to have. We haven't weighted heavily in on that. We've been so focused on, as I said, the AD feedstocks and the landfill projects.
Got enough to do it with.
We do. It's hard enough
on your
with,
plate
with
already.
those issues sometimes. Yeah.
Okay, great. Well, thank you very much. I'm running. Pause for. Oh, yeah, we have one. Sorry, Greg.
Just real quickly, Greg Esther at CASA. Sam, what do you think the advanced clean fleet rule will do to the viability of RNG?
I think it's a new challenge for the industry for sure, and it's necessitated a change in end use markets, right? I think the industry has tried to be responsive to what agencies like CARB want us to do with the gas, and we can be nimble and shift where we use the gas over time. But as Evan asked, does it destroy business models or nice, local use of the gas in fleets? Sometimes it could, for sure. And I think that is inadvisable. I don't think that's smart policy.
And then we have the added complication of Clean Air Act requirements in the South Coast and Central Valley, which makes use of the biogas challenging there too.
Yeah, exactly. You have historical uses in power for a lot of landfill projects that are now unable to, re-permit their engines and other things. And that's why a lot of folks started looking at the pipeline, honestly, to take the local air quality issues off the table, put it in the pipeline, directly displace fossil gas. And so I think if the state and local regulators just get a little bit more clear about what they're hoping to achieve with these projects, and provide the economic incentives to make those transitions, the business model can adapt and shift to other energy carriers over time. But if you don't have a smart strategy and you just say, we don't like X, that is not a good way to go.
Great. Thank you very much, Sam.
Thank you.
We have Chuck and Tom ready to go.
So this next presenter, we actually have two, Chuck Schmidt and Tom Card. There's a combination of phone and Zoom and others. So this will be a little experiment in, airwave technology versus internet versus Zoom.
Okay, well,
Okay.
welcome to Chuck and Tom. I ran into Chuck Schmidt some years ago as really being knowledgeable on monitoring methane emissions from waste facilities, landfills, composting facilities. And to kind of further on the point that Sam made, methane is really the issue when you're dealing with organic waste. And we can't have a solution for the using this stuff beneficially unless it reduces methane significantly. Like I mentioned, the Environmental Defense Fund 2%, 0.2% standard for all gas that's delivered and beneficially used can only contribute to 0.2% of emissions. And that's going to be an issue that's going to be talked about further. Let's see, Chuck has got a great consulting service focusing on methane emissions and other emissions from waste facilities. And Tom is internationally recognized for the assessment and control of odors, air toxics, and volatile organic compounds from waste facilities, written a number of books, written a number of articles. He's been chairs of various committees nationwide on this. And so I'm welcoming Chuck and Tom. I don't know how you guys want to proceed, but the floor is yours.
Okay, is Chuck available?
Chuck Schmidt?
Yeah, I don't hear him, so I guess we will continue and hopefully he'll get connected in the next 10 minutes.
So
Yeah,
I think Chuck is
Chuck
actually
Schmidt's on by phone, but whether he's actually on or not, I don't think I know.
Chuck White. We have Chuck Schmidt on both Zoom and phone. I think
okay.
Chuck Schmidt Zoom is currently muted, so we can ask him to unmute. Okay, I think you just unmuted yourself, Chuck Schmidt. So can you talk and see if we can hear you?
Can you guys hear me?
We can, and if it does get a bad connection, then we'll switch over to your cell phone connection. But right now, you sound like you might be good to go.
Terrific, thank you. Okay, well, to get started here, our talk is focused on methane emissions from composting, and we're going to cover, how these are measured and what are the methane emissions from composting. So, an outline of our talk is that, we're gonna talk about different composting configurations, how these emissions are assessed, and present data on what the actual emissions from composting are. There's a lot of composting people in the audience, but for those who are not composting people, we'll kind of review the composting technologies. Windrow composting dominates composting over the world, and with the exception of Europe and some parts of the United States, windrow composting is 90% of composting, and we'll show you what windrow composting is. A more advanced technology is called aerated static pile. And this can either be forced air, positive, in or out. It can be controlled or uncontrolled. Controlled aerated static piles now called CAFS systems that's been adapted for whatever reason. The control can either be a biolayer or a micropore cover. Gore Technologies dominates the micropore cover, but by no means they're the only one. Or some people place these aerated static piles just in buildings and then evacuate the building air to a biofilter control device. Also, there's in-vessel systems. In-vessel systems are more popular in Europe than in North America. These systems are normally fully contained or placed in a building, and we'll talk about that as well. So windrows, the big thing about windrows are they come in all sizes, and we'll show you what we mean by that in the next slide. The only process control is how frequent they're turned, and when and how much water is applied. Windrows can have air emissions control by placing finished material on top of it and wetting it, but this cover disappears in the next turning cycle. And these are photos of different composting operations, and you can see up in the upper right corner is how these composts are turned. And these are custom made machines that go through and completely mix the pile and rebuild it behind them. And then to show you the size difference in these piles, if you look at the upper left photo, you can see that these piles are just barely above the waist of that person, where you can look at the lower right photo, that pile is 16 to 20 feet tall. And those are both windrow technologies. And then the lower left photo is showing what this looks like, over a large scale. The next technology is aerated static pile. Most systems are positively aerated, which means air is blown up through the pile and exhausted over the top. Although there's systems that do negative air and systems that go both ways to optimize control or optimize the compost product. A significant number are micropore cover systems made by Gore or others. There are other cover technologies available. There's all sorts of different types of fabric and material that's placed on them for either air emissions control or thermal control over an aerated static pile. And this leads to like a near infinite number of aeration cover combinations. The most expensive implementation of this are buildings and micropore cover systems, which are substantially more expensive than the traditional aerated static pile systems. But as we'll see, these systems can also have very low methane emissions. So here's some photos of cast systems. These are difficult to take pictures of because most of the systems we work with are so large. But the photo in the upper left shows the air distribution system for a cast system. And then this photo on the lower right shows what these look like on top. And this is how we test the air emissions on a cast system using flux chambers. And then this next slide shows you photos of what a micropore cover system looks like. The photo in the upper left is a Gore bunker system that's supported by concrete walls to about waist height, and with the micropore cover placed on it. The lower right photo is a Gore system, the way most systems are done, and that's a system that covers the pile completely down to either a paved or an unpaved floor. And then the upper right photo is a photo of another manufacturer. I can't even remember. I think that's a Moore cover, micropore cover on a much smaller scale. And then here's the negative airflow systems. These the original cast systems were negative airflow, where they extracted air from the compost pile into a biofilter. The photo on the upper left is a picture of a facility in Oregon, and these dark piles. These are actually covered piles. This cover is more of a thermal cover than an air emissions control cover, and then the air is blown through this bark biofilter where you can see the steam coming off of it. And then the photo in the lower right is just a huge biofilter off of a huge composting facility located in Central California. And this is what this looks like if it's in a building. These are two building structures located in California. The photo on the left is an actual in-vessel composting system, and the biofilter is on the extreme top of that photo. And the one on the right is a biosolids composting facility that has a huge biofilter. The entire brown spot on the top of that photo is the biofilter for that facility. And then this is what a vessel composting system looks like. This photo is actually in China, and this is a compost facility that's placed inside concrete bunkers, and it has a mechanical turner that goes on rails that turns this. The advantage of the vessel systems are they can be compost much faster under certain conditions. And that shows you also a flux chamber measuring the emissions from that process. So now I'll turn it over to Chuck to talk about flux chambers.
Good job, Tom. Thank you. Can everybody hear me okay?
Yep.
Good. Well, Chuck asked us to talk a little bit about the measurement technologies for measuring fugitive methane and other species from composting operations. We thought we'd start off with that whirlwind tour of different technologies. Thank you, Tom, for that. So what's a flux chamber? A flux chamber is a device we use for measuring the flux. That's an engineering term, mass transfer, mass per time per surface area, from species of interest from an area source. This is an area source technology, and that defines compost. There's nothing but area sources. There's a variety of types of chambers. You can use static or dynamic. There are many academic chambers, and then there's one regulatory approved, and that's the US EPA recommended technology. It's a mixed tank reactor, uses a sweep air gas, and it's operated at atmospheric pressure, meaning there's no back pressure in the device, which would suppress, or there's no suction out of the device that would enhance flux. We want to get the flux at a natural state. The equipment and protocols described in the US EPA User's Guide. It was originally developed for diffusive flow sources. That's where you can't measure the actual gas flow. It's too low, it's molecular. And that's why the diffusion, that's why the dynamic chamber has a real strength. You artificially create that boundary layer of fugitive emissions inside the chamber with a sweep air gas that's intended not to disturb the event, but just collect the gases and allow you to take samples at equilibrium. Next slide, please, Tom. There you go. There it is. Oh, there you go. That's the standard dynamic flux chamber, EPA chamber. It's a 30-liter vessel. Gas is added from the sweep air gas to the ring around the bottom of the chamber. You see the two lines on the top. That hole in the port in the top allows the equilibrated gases to leave. Then there's a sample line from the chamber. It's about 30-liter vessel, about 0.13 square meters surface area. And at 5 liters a minute with 30-liter vessel, the equilibration time, the resonance time is 6 minutes. And the protocol requires 4 to 5 resonance times, or about 30 minutes before you can pull a sample. The sampling device on the left of the chamber here on a surface. This is over a contaminated groundwater plume, by the way, and diffusion up from the contamination. That's an evacuated canister for hydrocarbon sampling. Next slide, please. So what we have basically by design is a modified chamber. We work with South Coast to develop this for advective sources, sources with measurable flow from them, like compost sources, curing and compost portions of the process. We added an exhaust port stack to the chamber of different sizes, different diameters. The diameter is specified for the type and range of flow. We use a trace gas that's 10% helium with 90% ultra high purity air. And we use that so the dilution of trace gas in our samples will determine the amount of advective flow. That's an extremely important parameter in the calculation. We also added impeller for good mixing and sweep air added to enhance distribution of trace gas. And the samples are taken from a stack. This is all described well in the modification of the EPA technology in the South Coast Rule 1133.3 Attachment A. So this is what's required in California for measuring fugitive air emissions from area sources, in particular compost sites. Next slide, please. So here she is. This is the modified EPA chamber using South Coast protocols. You see a couple of differences. The air is added through that air introduction system, that cross member on the bottom, toward the bottom of the chamber. There's 57 holes in those lines to distribute the trace gas and sweep air as even as possible. Off to the left there, that little menagerie of wires and things, that's a little impeller system for mixing. The stack is adapted at a 6-inch diameter port to different sizes of stacks. We see here a 2-inch diameter stack, and you see the sample lines for sampling are up along the stack, and that's where the gases are pulled from, just like a stack testing method. The sampling here shows method 25.3, which is a total non-methane hydrocarbon analysis. Now, when we pull these samples, there's a condensable fraction and a volatile fraction. From the condensable, it's things like alcohols and whatnot. And from the canister, we get all the volatile, including the fixed gases, along with our tracer. That's where we get our methane from. So from this South Coast method 25.3, we get helium, methane, fixed gases, as well as condensable and volatile hydrocarbons. And that's pretty much what our clients need for permit requirements. Next slide. Tom, can you flip slides?
I did. You're not getting it?
Oh, I'm still seeing the flux chamber. Oh, here we go. Now here's the same chamber modified for advective flows with a 6-inch diameter stack. And if you know anything about point source testing, you have to sample at a certain distance away from the bend or constriction in a pipe and below exhaust of the pipe. So now we see a much longer, taller stack, 6-inch diameter, and the sampling taking place at the prescribed location for point source testing. And this allows us to sample mechanical wood chip biofilters that can go up to about 600 liters a minute into the flux chamber. And if we do this without back pressure, which is critical for the measurement. So this is, as Tom showed earlier, a biofilter that's associated with an in-building compost facility. Next slide, please. Okay, so species of interest, fixed gases, methane, carbon dioxide, oxygen, or helium trace gas, and others. Total hydrocarbons, less methane, and individual species, which is important for health risk assessment. Ammonia and other inorganic compounds, sulfur-containing species are typically not found at compost sites, but we do look for them on different occasions. Nitrogen-containing species, for instance, wastewater facilities, and odor, olfactory odor, which is a big deal for dealing with the digestate from anaerobic digestion. We'll get into that in a minute. So we can pretty much see most volatile compounds and important semi-volatile compounds, provided we have a regulatory approved analytical method for the analysis. Next slide, please. Simple calculation for flux. It's just concentration of species of interest times your sweep air, which is added and advective flow measured by helium dilution, divided by the surface area of the chamber. And here's an example for instance, hydrocarbon species measured at low concentration, microgram per cubic meter times sweep air flow rate. We would add to that advective flow, divided by surface area. So there's your engineering unit, mass per time per surface area. Now that's important if you want to do dispersion modeling, for instance, or global balance. You can take these emission rates, and then if you know the surface area of your source, you have input for a dispersion model, which is mass per time. For odor, the odor concentration is dilution of thresholds, and we treat odor just like concentration, which is very effective for measuring offsite odors once you have the flux chamber data. Next slide, please. So why do we use the EPA flux chamber modified by South Coast Protocol? First of all, EPA recommends this technology as the only in-depth assessment technology applicable for area sources. And that includes landfills, wastewater treatment plants, it goes on liquids, it goes on sludges, it goes on compost. It's the only regulatory approved method allowed by South Coast for active compost sites. We know the accuracy and precision of the sampling and analytical technologies we use. It's very, very sensitive. You're measuring the fugitive emissions at the highest concentration. So that coupled with low detection limits gives us a real good window into what's coming off these sources. It's spatially specific, which means we have to deal with spatial differences, which at compost sites, it's very heterogeneous sites, which means multiple sample locations. But the advantage of it is you can differentiate between different area sources on a single site that have the same emissions. For instance, we can see methane from a cast system, we can see methane from stockpiles, we can see it from the curing phase of the compost. So we can understand where all the sources are and what the level is by using this technology. Next source, please. Next slide, please. Okay, Tom, now the data.
Yeah, so this slide shows you, the methane emissions as a function of process day. And this particular process has 30 days under the cast and 30 days under cure. You can see that the cast methane, which is the blue or violet, is a lot lower than the cure, because in this particular situation, the cure is really uncontrolled. It's just a cure pile, and this is true for most controlled facilities, that the cure emissions are larger than the cast emissions. And so here's the real meat of the slide here, which I'll go through quickly because we kind of ran out of time. But here's where the rubber meets the road. And so these first 4 lines are public data on how much methane is emitted from composting. And so the official CARB number is 2 grams of methane per kilogram of compost input. And that's based on a literature review of papers that reported a range of 0.17 to 7.63. We did a R&D project for San Joaquin Air Pollution Control District in 2008 or something, or I guess it was 2014, called TAP. And that's completely public data. And there, for the cast system, we got 2.78 grams of methane per kilogram, and for the windrow system, we got 6.22. And another literature value I found in Australia is their official number is 4. And so the numbers below this are our numbers. And when I say not so public data, what I mean is all this data is on some public hard drive. It just has not been compiled yet. And so, and this data represents 2,000 to 3,000 data points. This is a lot of data, because whenever we make a hydrocarbon measurement on a compost pile, we get the methane value as a byproduct. And so we have tested digestate from a food waste digester in both windrow and with a Gore system. In the windrow system, it was 25 grams of methane per kilogram compost input, and for the Gore system was 0.2. But the note on this is that it's actually probably less than that, because we were confronted with both background methane and detection limit problems on this one. And so this could have been as low as no really significant methane generated. And then for green waste, our windrow data is all over the map, mostly because windrows are all over the map because they're uncontrolled and of all different sizes. But we only have limited windrow VOC data because they're basically outlawed in California. And so we really don't test those anymore. But the data in windrows we have is, averages 100, but granted, that's probably the worst offending windrows that we have tested. And so then for green waste for cast systems, I broke them down into two groups, VOC regulated, non-regulated. And everyone needs to know here that to operate a compost system in California under VOC regulations is extremely challenging. Many people have tried and failed. It's only the exceptional people that can successfully operate a compost system in California where there are jurisdictional VOC regulations. And in order to comply those regulations, they have to do a lot of different things with the compost process that were not normally done. And unfortunately, what they do normally increases methane. And so for cast systems where VOCs are regulated, they have higher methane emissions, about 25 grams of methane per kilogram compost, where cast systems that are not regulated for VOCs have much lower emissions. And we found they average around 0.25. And GORE systems on green waste really operate at the background detection limit level. Again, our methane data, we haven't really looked at this from a pure methane standpoint. All this data is byproduct data, but it is possible on most of these GORE systems that there really is no methane generation, and we're just measuring background concentrations. So when we say 0.05, we're talking average methane concentrations coming off that of 1 ppm or less. And on biosolids, the last category, I broke that into two ones too, because a normal cast, and all biosolids casts are regulated, the we test in California. And so again, on a regular cast that's heavily regulated, they have higher methane emissions, about 25 grams of methane per kilogram compost input. However, there's one system in California that's about twice as expensive because it has twice the surface area. And in that system has substantially lower methane emissions. They're at 0.5. And again, GORE systems are right at the detection limit background level, which is about 1 ppm of methane. And that turns out to be about 0.05 grams methane per kilogram compost input. And I guess one thing on this, the GORE systems are quite a bit of expensive. And so if you look at this biosolids one, if the cost of system A here is 1, then the cost of system B is 2, and the cost of a GORE system would be 4. That's the cost difference of these systems. So now talking about anaerobic digester waste specifically, composting is almost all composting technologies can be used to treat the waste, and I guess backing up, when anaerobic digester is done, there's a solid material that comes out, and that's what I'm talking about, is what to do with that solid material after it's undergone anaerobic digestion. And so we do have control data for that part of the process, and it's likely that that's the major methane, or the major methane emitter for anaerobic digestion is the processing of this digestate waste. And so with that, I think we went over a little bit longer than we wanted to, but is there any time for questions?
Yeah, I'm back on here again. This is Chuck. A very detailed and excellent presentation. We haven't got much time for maybe more than one question, and I've got a question. So if anybody wants to step up and ask a question, please do so. No? Online? Oh, one question, short.
Okay. Well, I'm just wondering if there's been a lot of.
How's that? Okay, thank you very much. All right, Michael Cohen from University of California Cooperative Extension. Question about incorporation of biochar into compost piles, and it's been done on a field scale. Now there was a recent study from UC Merced showing a 84% reduction in methane emissions just by putting in a relatively small amount of biochar. Either of the speakers, Tom or Chuck, are they aware of this being done at a commercial scale or something for the future?
We talk to the biochar people all the time, but it's done at such a small scale, and we've never actually officially tested it. But you know, it's completely believable, because it offers a lot of benefits, not just the methane issue.
Yeah, nitrous oxide too. The study in Merced was done on a field scale. So, I mean, it was just published 2022. So, yeah. All right, just putting it out there. Thank you.
And I guess the bottom line I get from your presentation, Chuck and Tom, is that you just simply can't take waste out of a landfill and put it in a compost pile and think you're not going to have any methane emissions. And the issue there is that it takes some significant amount of time and effort and expense to monitor compost piles to make sure that you're doing everything you can to minimize methane emissions. It's certainly doable, but it's something you can't ignore, and you've got to focus on your how often you sample and to the kind of sampling system you use, like used by Chuck and Tom. So is that a fair representation and summary of what I heard?
Well, it's not exactly right, because if you have a heavily capitalized system, and that's what the GORE system is, it's very expensive. That essentially is zero. You know, it's not exactly zero, but if you had an anaerobic digester with a GORE system, and when I say GORE, you know, I'm not trying to sell GORE systems. It's achievable with other ways, but it's achievable at a cost. And so if you go to that on composting, yes, I think you are essentially zero methane. But if you go to a normal composting facility, you are going to get methane.
Fair enough. Okay, well, very good. Thank you very much. A round of applause for Chuck and Tom. We're going to move on to my good friend, Evan Edgar. I've known him for, I don't know, 40, 50 years.
1988, Golden Waste Board.
And he's clearly a spokesperson for the solid waste industry. Certainly a spokesperson for himself, I can tell you that. But I always love Evan and his take on the challenges of managing municipal solid waste and other types of organic materials. Evan's got just decades of experience in solid waste management. He's a registered civil engineer. He's a co-founder of the California Compost Quality Council and the California Compost Coalition. But I've asked Evan to see if he can give us a kind of his take on what the future is of energy from organic material, organic waste, and is it realistic? Can we do it? What are the challenges? What are the obstacles? And so I'm waiting to be edified by Evan.
Right. My name is Evan. I'm a garbage man. It's a 12-step program to recovery, and I'm in recovery all the time. So we're going to talk about the circular economy. It's the biggest buzzword. And I started with Chuck. It was about recycling, and they came up with sustainability and greenhouse gas, and now it's all about the circular economy. And we've been doing it for 20 years. The solid waste industry was hard to decarbonize back in the 80s and 90s, but we've been at it for a long time. So, and what CARB wants us to do is recarbonize, but we're not going to do it because we can do a lot with organic waste. So my presentation will be about that. And we are the circular economy now. You know, people talk about it, but I've been at it with Chuck for over 20 years, developing the circular economy. It's nothing new to me, but somehow it's a buzzword that is, now people say it and they think they do something new with it. To actually what's going on in today's policy, the disrupting the circular economy of today for a global recarbonized economy of tomorrow by digging up lithium and cobalt and mining our way out of climate change, which is wrong. We have all this organic waste today. We can do a lot of low carbon fuel with it. So we got the Renewable Portfolio Standard, we got the Biomap program, we got Climate Action Reserve, we got cap and trade dollars, you got all types of grants, we got 1383, and I like what Cara Morgan said, there's no turning back. The Low Hoover Commission is going nowhere, there's no bills. So full steam ahead, and we're net zero greenhouse gases, and we've been for a while using a definition developed by CARB. What is net zero? The waste industry in 2018 data was 3.7 times net zero. And if we do all these policies by 2030, we'll be about 10 times net zero. Waste Management Inc. had a sustainability report out there, 3 times net zero, and they're going to be 4 times net zero, and Recology is 8 times net zero. So we're net zero now. We're making carbon negative fuel now. We're making organic compost now. It's not a pipe dream. It's not in a book from the MacArthur Foundation about circular economy. It's actually, we're doing it. And people forget about that when they talk about policy. So the goal is, it's not a goal, it's a mandate, 75% by 2025. That's SB 1383. And we had another bill, Chesborough, AB 3401 was 75% by 2020 for the blue cart. So where are we at? We're at 40%. At one time we dipped so low, we were at 37%. And then with, China stored as part of it, you see that dipping line about how much waste reduced as part of AB 939. And then with a new economy, and then the pandemic happened. So a lot has changed. And the methodology has changed. AB 939 has new math, and 1383 has Article 2 Chuck White math with regards to what it counts as disposal and what does not for emerging technology. So CalRecycle has 4 ways to keep book. So there's a lot of ways to go about it. ADC does not count anymore. Finally, after 2020, that used to count as recycling. I don't know who started that. Oh, it was me, that Yolo County in 1993, but it's supposed to sunset in 97, which took until 2020 to sunset. Disaster debris is big. That counts as disposal. We had a lot of fires. Cheap disposal is another reason. It's too cheap to meter. That $1.40 a ton was AB 1220. It was an Easton bill that Chuck and I worked on. Remember that? It was $1.40. Guess what the tipping fee is today for integrated waste management account? $1.40. If you did a CPI on it, should be $3 a ton, but it's not. Back in when they started that bill, that was 97% of the CalRecycle's budget. Today, that $1.40 is only 3%. So somehow it's way undervalued, and we need that money for future grants and future infrastructure development, which I talk about. And having a department, Arnold Schwarzenegger blew up the boxes in 2010, and it's been bad news ever since. I think that with a waste board, we had a lot better stakeholder input. We had a lot of diverse opinions, and we had a lot more meetings about it. So missing the waste board, and then we're at only 40%. But what CalRecycle wants to do is be zero waste, have a zero waste plan, spend $2 million, and that's due on July 1st, 2026. But they took the playbook right out of CARB. CARB had a scoping plan. They want to be carbon neutral by 2045. I'm going to model it in 2035. And let's look over here and be carbon neutral in 2045. And what about the steps to get there? What about the 40% reduction of methane we needed by 2030? We should be focused on that at the scoping plan, and they were not. They want to kind of have this perfect carbon future neutral, and that's what CalRecycle wants. Let's have a zero waste plan, and in 2035, 2040, and 2045, they're going to model it 3 different ways, how to get to zero waste, but nothing about how to get to 75%. And that's where I come in, because I'm the 75% guy. How much waste is enough? Well, we can get 75% by 2030. That's the goal I'm looking at. So CalRecycle has an RFP out for zero waste, but part of it, they should have a 75% benchmark and what to do with all the organic waste to get there. It's crazy because what we do in our sector, in the solid waste and solid waste sector, we're the most cost-effective program under cap and trade. All the money's invested in the cap and trade. The compost and AD, anaerobic digestion, can do it for about $50 to $60 a ton invested. ZEVs are $1,000 to $3,000 a ton invested. So we are the best value for cap and trade dollars. And for every $1 invested in compost and AD, you get leverage $4 of public and private capital. So there's $150 million coming up in grants. So that's going to be released, and we get 4 times on private capital and public capital. We're talking about some real money, a billion here and billion there. So I'm doing my best to work at CalRecycle to focus on 75% by 2030, and don't get lost in this shiny object of being carbon neutral by 2045, because we may not even get there at the rate we're doing on climate change. So we need some 2030 short-term plans for short-lived climate pollutants, and don't kick the cans and bottles down the road again. You like that, Chuck?
I like it.
So 1383, Carr did a great presentation, 50 to 100 facilities, new or expanded for compost and AD, about $3 billion. it'll take a lot of money to do this, and the train has left the station. Energy is doing a great job on investment. We are all in all sectors. The wastewater treatment plants with Casa and Kester is doing an excellent job on getting feedstocks into the wastewater plants. So there's a lot of great technology out there, a lot of money out there. So where are we at with all this money? So the $155 million is going to be noticed probably early December. It'll be on a December 19th agenda is where the $155 million is going to go and who's the winner. And we need that. The allocation of that is $56 million for anaerobic digestion, $78 million for compost, $15 million for pre-processing, and $5 million for in-vessel composting. So that's about, that's where you get $155 million. But it's oversubscribed. There are 68 different projects that are asking for $387 million. That's 2.5 times oversubscribed. So, which is good. We have a lot of projects in a pipeline, not the PUC pipeline, but in development stages, because I don't need no PUC pipeline. It takes 3 years and $3 million. I'm community scale. We put it right back into the tank. I don't need a lot of transmission losses. I don't know VMTs, vehicle mile travel. When you go community scale, you keep things local. The local circular carbon negative economy. We're doing it, and this money helps. However, this money's drying up. We're in a budget deficit. Cap and trade dollars not being allocated here that much. So that's why I'm recommending a tip fee increase over $1.40 a ton, go up to $5 a ton to raise 300 million to have this every year. What we're seeing for the $155 million, it will divert about 1.6 million tons a year. And that will be probably about at a 25% rate to SB 1383. We got to be at 75% by 2025. And in 2021, we're at 4%. 4%. But I don't think we can kick that goal out to 2030. If any, there's no pause per se for 1383, but I think what CalRecycle should do, and part of the zero waste report, and maybe it should bring back the recycling commission. It was a commission set up a year and a half, 2 years ago to make recommendations, but they haven't met since June 2022, been almost a year, a couple of months. But we need some leadership here to really get some more money, whether it be part of a bond that's coming up or more cap and trade money. But this is a great start. It's the first round. We need 3 to 4 more rounds of this type of money to meet 1383. What's missing from here is there's no bioenergy. CalRecycle will not fund bioenergy. It's thermally. So $0 there. And what I found out the hard way, I have some applications in I got rejected on that were kind of too small and emerging technologies, that compostable paper is not involved, only food and green. And the biggest opportunity is what to do with compostable paper and non-recyclable paper. So hopefully next month we find out who the winners are. They come in $10 million chunks for a lot of covered compost in the valley, a lot of AD on the coast. There's a lot of opportunity. So we thank CalRecycle for deploying that money. And then the contracts will probably be started, notice to proceed in March 2024. And you see a lot more in the pipeline. This is only the first $155 million. There's a lot of other projects coming online. So full steam ahead, a great public-private partnership. We're going forth. So when I talk about compost and AD, is that compost basically in the valleys where you have agriculture, and AD is mostly on the coast. And so I work a lot of compost up and down the valley. We have agriculture there. It's less cost, less land, less labor, easier technology than, so you see a lot, and that's where the markets are at. And so we can haul out organics from the urban center and go to these valley compost. And when I talk the valley, I'm talking the Central Valley. Salinas Valley has good compost. Napa Valley, Ventura, Santa Clara Valley down there in Ventura County, Imperial County. It makes all sense to have covered compost where you have the markets and where it's cheaper. So you see that. You see a lot of compost in the valleys, and you see AD on the coast. Now the coast is higher labor, higher land, more expensive, but we have better fleets, more demand, and it aligns with a lot of urban POTWs. And the digest state that we're talking about can haul to the valley landfill. So that's a trend I see. This is a map up there, is a CalRecycle report from 2015, but I added the big green dots at all the new AD plants I'm working on and that I know about. And there's a lot more compost facilities too. So this influx of money, 155 million, would put more green dots on the map, as well as more big blue dots in the valley. Now, I'm going to talk a little about market development. CalRecycle is supposed to do a market development plan as part of their annual reports. They haven't really done one since 97, I think. The last time they did a wood race report was 95. So what we're really missing is a lot of leadership on what happens to all this 1383 waste. Where does it go? 2014 is the base year to get 75% reduction, and we have a good 2018 waste characterization and a pretty good 2021 waste characterization. And I don't think we're going to get to 75% until 2030. We're not going to make it in 2025. So the zero waste plan that CalRecycle is working on should really get into 75% by 2030, should be a benchmark goal. And that's what I'm working on. I'm making my road show down to Swana on Thursday to the Swana Legislative Task Force. I make Bioenergy Association of California, from CSAC to League of Cities. I'm shopping this. I'm the 75% guy. So what we need to do on a green waste market, get to 75%, we have a great runway already. We already got 8.32 million tons of compost and mulch in the marketplace in 2021, and only 2 million tons of disposal. And we got some compost going to D3 RINs. You get more value making a D3 RIN out of them through anaerobic digestion, like CR&R, and EDCOs have one going in. So we have a great start. All this compost is going to 75% of the market is agriculture. What I'm trying to do with green waste is keep it clean green. When you commingle with food waste, it's about 3%. You have to send it to a permitted compost facility that has food waste. By separating clean green out, I do a lot of ag composting and carbon farming. I'm the carbon cowboy. Up and down the state, we're doing small scale within Title 14 regulations for under 12,500 cubic yards. Water board's 25,000 cubic yards. We're busting out these windrows and some casts all throughout the ag sector. We use a compost on site, cut down on VMTs, carbon farming, save 40% water, and we sprinkle biochar on it too. We're the biochar people as well. So there's some more room to go there more to divert about 1.5 million tons of green waste is still in the waste stream to get to 75% for that alone. So that's an easy plan. Green waste development, get a little bit of AD out of it. We can move up to about 1.4 million tons of D3 RINs out of green waste. So that's a balanced portfolio. Now, this is for food waste. Food waste has got a big lift. That's the number one thing in the waste streams, about 5.8 million tons in 2018, down to 4.3 million tons in 2021, mostly due to the pandemic. So we lost a lot of tons. Not too many new programs were going, but from there you get a D5 RIN. When you go food waste, anaerobic digestion is different RIN value, different market, but food waste should be going there. A bunch of food waste, compostable paper. It's tough at the compost facilities, especially with all the different PFAS, microplastics. You can add up the issues every time you turn around. Keeping compost clean and green is a goal, but food waste has more high-tech markets like anaerobic digestion. But first, we want to feed hungry people. There's about 0.32 million tons a year of edible food recovery we got to do. And all my clients were on that. We get grants for it. As any program we put together, we have edible food recovery program because a lot of my Italians are on board of directors of different food banks, and with Catholic guilt, you got to feed hungry people first, because stealing from wasting food is stealing from the poor. So CalRecycle has good grant programs there. We're going to move about 0.32 million tons a year of edible food, and there's some room to take food waste at compost facilities. I put about 1.34 million tons a year by 2030, but the big lift is taking that nasty food waste, putting it through pre-processing, and take it to anaerobic digestion. A lot of CASA facilities, they got 20 million early this year, and on that list, there's a lot more wastewater treatment plants stepping up at the public sector. That's a good fit in urban sectors to use a CapEx instead of building a 25 million standalone AD facility. Greg Kester has capacity waiting for us. He has where's Greg Kester? There he is. He has report outs on how much capacity they do have at these wastewater treatment plants. So we're teaming up with them where we can because we're quasi-public sector, and together we're essential public service by fulfilling the need. That's what we learned during a pandemic. So the big list is taking food waste, pre-process it, take it to wastewater or standalone AD, and making low carbon fuel for the RNG to put it back in the trucks. When I make RNG, I make it for our fleets. I don't make it for a tomato plant in Modesto that needs help because they're hard to decarbonize. That's CARB thinks we can do that, but it costs $3 million in 3 years to put in a pipeline. I don't need no stinking pipeline. I have my tank capacity right there in the tether fleet in a parking lot next to the AD facility with no losses. A little food for thought there. The biggest thing is wood waste. The wood waste is the second biggest thing in a waste stream, almost 6 million tons a year. Actually 5 in a landfill, but once again, CalRecycle hasn't had a report on market development since '95 for wood waste. No money for cap and trade money. Chipping and grinding is not a market. Somehow in all the reports I see, somehow you chip and grind wood waste and that's supposed to be a market. It's not, it's a process. So what do we do with all this wood waste? So baseline against 2014, we got good 2018, 2021 data. Treated wood waste, you got to dispose of it. You can't do much with that. And that will be there another 1.7 million tons by 2030. And then we have to get that non-treated waste, get that to different markets. So there's a lot of diverse markets for wood waste. The traditional market is biomass combustion, but we're being crowded out by the forest sector. 80% of the wood waste going to these PG&E plants that online biomass from the 80s, own biomass, using fluidized bed. And we used to get 1.5 million tons a year, and each year we're crowded out. In 2021, we only got 900 million tons a year. We're losing half the market share, and we're going to lose some more. The biggest opportunity is biomat program. We get great pricing, forest, ag, and urban sector. So it's a limited market. And so I got a lot of projects up and down state doing clean biomass conversion, making biochar, making renewable energy. That's about 250,000 tons a year. Then we got procurement. 30 years ago, I think me and Chuck worked on a Caltrans bill to have Caltrans buy mulch and compost. And we had another bill to make them buy it. 3 strikes and you're out. Caltrans talks about it, and the metrics aren't there. They're less than 1 to 2% of the market. But there's 1383 procurement that maybe the counties and the parks can use some of that mulch. They got to buy it back. So as a blend portfolio, there's some opportunity there to move some. Compost facilities can take some wood waste for CNN ratio, especially biosolids. We need to bulk it up, and there's a lot of ag and waste in the valley using there. But somehow the Sierra Clubs think that we can take all this forest sector waste and compost it. I don't know where they're coming from, but they don't understand CN ratios. We can't even take care enough CN ratio from our own wood waste. We don't want ag ag waste is cheap, so we have that in the valley, but we're not going to compost forest sector waste at commercial compost facilities. The biggest opportunity is biomass to hydrogen. And that's not just for the urban sector, but it's for the ag and forest sector. That's where the big opportunity is at. Huge. So hydrogen is out there. I'd rather have the solid waste industry pivot from RNG to hydrogen. That's a great play, but bypass the ZEVs because you have to import everything in the global economy when we have all the biomass here in California we need. There's no reason to dig up the Congo and the cobalt and lithium in South America and nickel in Canada within social justice to import stuff here to China to make us do heavy duty batteries that we lose half our payload and cost twice as much. It makes no sense on top of 1383 to put advanced clean fleet rule on with heavy duty ZEVs. Will this triple your garbage rate? So bad news there, CARB. So this is the biomass plant. It was ready to be hooked up 2 years ago, about a year and a half. PG&E interconnection takes forever to strangling that plant. So this is the forest sector. It's a 2 megawatt. It makes biochar. Great plant. All these throughout I have a lot of these throughout the hills. And we sponsored a bill 3 years in a row to kind of have an organic waste scoping plan for the state of California. We have forest sector and ag all competing on different policies, different incentives, different technologies. And each year it gets killed by whether it be somebody kills it at the governor's office because it may cost too much money, but they should do the agency should be able to do an organic waste scoping plan for the 3 sectors on their own, like they used to do in 2012. They had a plan, a bioenergy action plan in 2012. Has been updated for 10 years. Why is that? We had 3 bites at the apple to try to make them do it again. They won't. So once again, we have incoherent policies with different silos and different sectors trying to move organics around in wood waste. But the big opportunity is hydrogen. Now, you can make hydrogen many different ways, and that's the debate in the Capitol. Is it green hydrogen? Is it blue hydrogen? Is it brown hydrogen? I'm colorblind. I'm a carbon intensity guy. What is a carbon intensity of the hydrogen should dictate if it's renewable or not the sources, not the technology. And I'm not part of big coal or big oil when I stand up here, because environmental justice thinks that's what hydrogen is about, is employed by big oil. I'm not into big oil, I'm into big soil. Big difference. You know, from all this digestate and biochar, actually put it back in the soil. So I don't know where they're coming from, but from all the different technologies out there, that's the next wave of the future. So all this biomass left over from urban, forest, and ag, they have a home. And so hopefully in legislation next year, they can define hydrogen based upon carbon intensity that is equal or better to a certain benchmark, whatever that could be, which is undefined. Now, this is my carbon chart of carbon intensity borrowed by CARB, and this is all the different transportation fuels. And as you see, you know, diesel's 100.25 on the grams of CO2 per megajoule, and using CNG goes to 88. Well, we're down there in a negative territory. The first carbon negative plant I worked on, well, first one there is, was South San Francisco Scavenger. I got a CEC grant for 2.6 million. And we're minus 23 grams of CO2 per megajoule because offset methane. And then if you have different blends of food and green, it's variable. The Napa project, we got a provisional carbon intensity of minus 150, 165. So it varies. The more food waste you have in it, the more carbon negative you have in it. However, the more green waste you have under D3, you got more money on a RIN value. So it's counterintuitive, but a lot of good carbon incentives. Dairy is way down there. It's almost minus 330, but so there's a lot of good carbon negative fuel, and it's a niche market to put back in the fleets of California. We have enough RNG to fill our trucks. Let us do it till we can make hydrogen. And from that RNG, you can make hydrogen later. Oh, you saw those ZEV batteries crashing. Zero emission vehicles aren't zero. It's a big lie. I stand up at this microphone every month in front of CARB and tell them this is a big lie. You know, you want ZEV, you say zero emission vehicles and the decarbonization breath, they don't go together. The carbon intensity of ZEV batteries are average of 75 grams of CO2 per megajoule. You got to charge a battery with a California grid, which is 24.39. And then you got to make the battery with a life cycle assessment. We had a bill this year, AB 1012, where we made CARB to do the life cycle assessment for ZEVs. They're tone deaf. For 2 years, I stand on that mic. They don't answer my questions. CARB staff don't want to hear it. The Union of Concerned Scientists was concerned about this bill. They were concerned about science. They didn't want any transparency or have that knowledge out there. If California's spending $10 billion on ZEVs, they don't really need to know carbon intensity, do they? They should, and I can't get it through. So this bill is a 2-year bill, I'll bring it back next year. And so based on European studies, and the European Battery Directive has been around for a while, and using their data, it's about 75 grams of CO2 from megajoule. So it's a bad deal. Electrification and ZEV batteries for the heavy duty sector, keep it passenger, I'm okay there. But let's talk about the truth there. But CARB can't handle the truth about carbon intensity, and the Union of Concerned Scientists don't want to know the truth about science. It's an amazing world we live in when we're up against critical mass in the near term on climate change, and we're still want a 2045 carbon neutral future that is tough to achieve when you can't even address near-term opportunities in front of us. We are misunderstood with the environmental justice community. They see me with a cowboy hat on, I think I'm dairy, oil, or something else, or a garbage man, which I am. But really, we've been decarbonizing for years with regards to being net zero now on greenhouse gases, 3.7 times in 2018 and 10 times by 2030 with all these policies. We're off diesel. We invented RNG years ago. We're knocking off NOx. We're near zero on NOx. We're down 99% from the diesel days. We are off pesticides. You know, we're making organic compost registered by CDFA. And we're the zero heroes. But one thing we're not doing, we're not off landfills. That's the biggest dirty secret in California, is that we met the low carbon fuel standard. We met the RPS for renewable energy. We met the greenhouse gases. But we're nowhere near on landfills. We're still at 40%. Recycling means 60% diversion. So we need a lot of work there. So not really the zero heroes, but when it comes to transportation and energy and carbon farming and getting off pesticides, we're doing a hell of a job. I tried to tell this story, but it's on deaf ears, but I don't quit. I keep on telling the story. So with that, that's my presentation. Net zero now. Thank you.
We don't have time for questions right now. We have to move on to our last speaker. Let's see. Who is our last speaker?
Stand or sit? Like to sit or stand?
Got it. All right, our last speaker, James Fresher with SMUD. I talked to Heidi Sanborn, an old friend of mine who's on, I think she's executive director now of SMUD, and she said they're doing a lot on biomass to energy at SMUD, and the guy to talk to is this gentleman. And so we've invited him to come and tell us what the plan is for SMUD to use biomass energy.
Awesome. Good. Yep. All set. Thanks for the opportunity and inviting me to speak. It's actually a really fun perspective to kind of bring to the conversation, because we got to hear a lot about the technologies and the policy and really enabling kind of biomass and this transition and the GHG pathways that we're seeing emerge here. And so I get to walk in and talk a little bit about from the utilization and the demand side and the utility perspective on how we're thinking about using these technologies and how we're thinking about using biomass and how that feeds into our plan. Just a little bit of background real quick before I jump in. So SMUD is the sixth largest community-owned utility in the United States. We've been around for about 75 years. And most notably, in 2020, we adopted our 2030 zero carbon plan. This has really set the tone and direction for what we're trying to do as a utility. It is us looking at all of the energy that we provide to our community, whether it's through our 5 thermal power plants that we own and operate, how we engage with the market and the different renewable energies that we procure, and looking at how we remove carbon emissions and greenhouse gas emissions from that energy portfolio. Not just from a net standpoint, but what does that path need to look like in order to get to an absolute zero carbon goal? And this is a little bit of a tout sheet that kind of talking about SMUD and who we are and what it is that we do. When I get to this slide, I also like to call out that we have right around the 7th worst air quality in the nation for cities that are comparable to our size. Kids in Sacramento are more likely to get asthma than the average American child, largely due to air quality. And so it's not just this is a global major issue and something that we should all be concerned about, which it is, but this is something that's very tangible to our community. To the extent that we can invest in eliminating greenhouse gas emissions, utilizing these emerging technologies, especially ones like biomass that have the potential to even be carbon negative, it has a very real local impact. And that's something that we like to lean into. For us, it really stems from the direction that we get from our board. As a community-owned, not-for-profit utility, we're really looking to do what is best for our customers, our community. And that includes affordability, it includes reliable electricity, but it also includes that component of forward looking. So in 2020, our board declared a climate emergency declaration that translated into our zero carbon plan that was published in 2021. And it's been the driving force for how we're thinking about procuring energy, how we're thinking about developing these new research and development projects. One of the groups that works in my department is research and development. And this plan has been something that's been really exciting for us, because when I take a step back and I look at the technologies that we used to be really investing in, a huge amount of our effort was at the long end of the horizon, the what's happening 10 years from now and what's happening 12 years from now, really operating on that kind of traditional utility timeframe. But what's happened as we've started to look at 2030, which is terrifyingly close. As we've started to look at 2030, we've had to zoom in on those technologies and opportunities that are much more close to market ready, that next step technology that we need to answer those immediate questions on. And it's one of the reasons why biomass and generation of hydrogen really rises to the top of the list, because it represents a fuel that can help us make this transition, that can take that step, and it doesn't require innovation or development of technology that is absolutely unfounded or doesn't have any clear path forward. As you heard, there's a lot of technology paths forward. There's a lot of policy conversations that are moving forward that directly support this type of opportunity. The zero carbon plan, more specifically for us, was broken up into really 4 categories. It's the natural gas repurposing of our power plants. So like I mentioned, we have 5 of those natural gas power plants. 2 of those power plants being retired, and then 3 of those power plants as part of the plan would be transitioned. That transition could be to alternative fuels, for example, hydrogen that we could be generating using this woody mass. Second is proven clean technology. So further investment in things like solar, geothermal, batteries, energy storage, the technologies that are growing and expanding, but necessary for reaching this overall goal. Understanding that we can't just solve this problem by going out to the market and saying, well, we're going to buy a bunch of batteries and invest in a bunch of solar, and that'll make the system work. That there's a baseline load, a baseline component that fuels like hydrogen can really bring to the table, that provides that reliability and also helps us make sure that we're being thoughtful across the board in terms of supply chain and embedded carbon and the technologies that we're installing. Furthermore, we do acknowledge that there is a component of this technology in the zero carbon plan that does need new technology. It does need new business models. So we're constantly looking for partnerships to build that technology forward, to use that technology as part of the solution. One of the things that we're very proud of is that because we are a vertically integrated utility, we own our own generation, our own distribution, we have our direct customer relationships. We actually become a very strong demonstration point for what is possible and how we achieve this destination and this solution. So as we're thinking about what a demonstration project looks like for using biomass or using woody biomass to generate hydrogen, we are the right size to help with that. We are the right size to demonstrate that. We have access to our thermal generators to actually bring that online and see it work and be a role model for that future. And then all of this underlying it is that it's not just a select few of our customers that are on this journey with us. It really is all of our customers. And so to that end, the financial impact is a very front of mind component for us. It's not enough to say we spent tenfold the amount of dollars that we would have otherwise spent, but we did it. We have to make sure that we're taking an affordable approach to delivering on this goal. At the end of the day, for our customers, we're thinking about what that local air quality looks like. And so if that's taking a diesel truck off the road, if it's hydrogen or if it's electric, it's having that impact on the local air quality. That bottom line benefit that our community sees is the same. And so thinking about that impact and not necessarily the individual solution becomes very important. At the same time, as we're moving into these new technologies, as we're developing these new facilities, as we're thinking about where this energy is coming from, Oftentimes it's requiring new jobs and new industry to be created around that. And seeing that those jobs and that industry benefits our local community becomes a very critical component for us, and one of the metrics that we evaluate our success based on. And then at the end of the day, by being that demonstration and proving ground for the technology, really giving that as a showcase or role model opportunity for California, the country, and anyone else that wants to pay attention to show how we can do it and how we can do it here first and how it works, both affordable, reliable, scalable, so that the solution can proliferate. And the things that work are the things that get highlighted. I've got a chart here that talks a little bit about the growth that we've seen over the last 10 years in our renewable generation. Biogas and biomass are a considerable component of that, with 19 megawatts coming on. The thing that I like to call out is that 2020 walked us through that initial climate emergency declaration, and we added 663 megawatts of renewable generation over that 10-year period. But as we zoom in on 2021, which is 1 year removed from last year's data, but I like to highlight that year because it is the year that the zero carbon plan was adopted. As we zoom into that particular year, we added an additional 200 megawatts in that single year of renewable generation. So basically 1/3 of the generation that we had added over the 10 previous years. I'd like to highlight this slide because it emphasizes the speed at which we're trying to move and the cadence that we need to push in order to have this type of meaningful impact by 2030. The other thing that I'd like to call out on this slide is that we're not going to get there by just relying on one technology. We're not going to get there by thinking about if we can just do carbon capture and sequestration, if we can just do battery energy storage, if we can just get that next pump hydro project. When we're talking about the scale of retiring and transitioning away from thermal generation, natural gas-fired generation entirely, the challenge is that we need all of these technologies. We need a portfolio of solutions, and it's not a matter of relying on one individual thing, but the right composition of technology that actually enables that future. And when we think about the plan, it's also important to highlight that it's not a matter of kind of snapping your fingers and saying, okay, it was natural gas, now it's hydrogen and batteries and solar and wind and geothermal, and we can serve everything that we were serving yesterday with the same level of reliability and affordability tomorrow with these new resources. Because in parallel with this journey, there is significant electrification going on. That's both in the building sector and the transportation sector. So as we look at kind of what occurred last year in 2022, just about 1,300 new residential and multifamily electric homes. We saw now that we're up to about 32,000, just over 32,000 electric vehicles. As we scale that forward, there's about 1 million to 1.2 million electric vehicles in the Sacramento area. And the idea of all of those vehicles being electric and the impact that needs to, that will have on our electrical system. As an electric utility, which is traditionally thought of as providing power and energy to your home and to your business, something like a potential 1/3 of our kilowatt hours that we deliver to customers might be specifically for the purpose of transportation. We genuinely become a provider of services for the mobility sector in addition to the household and business sectors as well. And so it's important to think about that, because when we ask the question of, is there enough fuel from a biomass standpoint to support this future? Is there enough solar to support this future? How much raw material do we need to have to build the batteries to support this future? It's not enough to say, where have we been? We have to make sure that as we're looking out forward, we're pairing that with where are we going? And it's not just the transition away from natural gas, but it's also those parallel journeys for electrification in people's homes and electrification of people's vehicles. And so it amplifies the challenge, not just from a standpoint of, can we do it or how much, but also how far in the journey will transportation electrification be as we're getting to 2030? Do we need to plan for 10 of these types of plants, or do we need to plan for 2? And so managing that uncertainty and partnering with the industry and having these types of conversations helps us understand just what the technology is capable for. And similarly, as we engage with the mobility industry and the transportation sector, understanding what we think the actual adoption curves and profiles and number of vehicles that are going to exist in our territory will be. And so it becomes a very complex problem. And it's something that conversations like the one today, I'm excited to hear all the thought that's going into kind of the policy and the direction and establishing that baseline for how this becomes part of the future. When we look at our service territory specifically, the thing that I like to call out is that really there is an abundant biomass resource potential. There's a significant amount of fuel that can be used to generate, for example, hydrogen. But it's a very significant challenge to go from, yes, it's theoretically possible, in moving that into a point where and the policies are in place that support it, and we can do it economically, and we can have sites and locations within our community to do that are either nearby the point of consumption. For example, if we're using it to generate hydrogen that might power one of our thermal power plants, can we do that near our facility, or does that need to be done through a pipeline or through additional development of infrastructure? And so having those conversations early and planning forward is how we get to that point. We have a strong baseline that says there's enough fuel to have this conversation. There's enough of an opportunity to have this conversation. But it's not just, is there enough fuel? It takes that larger ecosystem conversation to really make this work. Thinking a little bit about where we're kind of having some of that conversation today. We have an active project with Moat Energy that we're doing right now, which is looking at how to best utilize the woody mass that we clear out of our transmission lines. Historically, this has been something where we have to maintain our transmission lines. We have to maintain the clearances. We have to clear the forest. And even more so after we go through, oftentimes other utilities, CAL FIRE or otherwise, come through and have to clear further than we do. And so there's a significant amount of woody mass that results from that. It's something that is a cost to us to manage, but at the same time, historically, it's also a cost for disposal. And we get the opportunity to ask ourselves, is there a better way to use that biomass? Is there a better way to use that fuel to look that forward? And so what this project is doing is it's starting by doing that site evaluation. It's starting to look at what that stock intake process looks like. Where would trucks need to drive? What would the carbon impact of those trucks be? How close can we get this to an injection point into a pipeline? How close can we get this to one of our thermal power plants so that we could actually power it directly? We're starting to have those conversations, not just in a feasibility standpoint, but what would it cost? Would it be cost competitive with the alternatives? How does it compare with the embedded carbon impact of something like a battery energy storage system? And really bringing those more difficult conversations forward so that we're not avoiding the topic, we're rather acknowledging it, putting data side by side and understanding how competitive it can be and where it fits in the stack of solutions that we have. Because it's not just a single solution as we're thinking about it. That stack of solutions really is just that. It's a portfolio. And so as we're looking forward, as we're thinking about the role of biomass and organic material, and really at the end of the day, the ability to generate fuel that can power the transportation sector and the utility sector on the electricity side, what is the right timing? What is the right cost? And when do we bring that opportunity into our portfolio? So it's a very front of mind topic for us, and something that we're very excited to be working with the broader industry and community to be bringing into our zero carbon portfolio. One more slide here, just as we think about kind of what that looks like, bringing it into the portfolio. It's today a smaller conversation, but to be serious about this, it has to scale into the actual bulk generation of the fuel and potentially distributed generation for point of consumption. It has to go beyond that single site and into a proliferated technology. We have to overcome cost barriers. We know that this is a cost impeded type of technology today. And so through grants, through incentives, through financial support for the technology, we have to be able to move past those. From our standpoint, because we do tie a lot of the woody mass conversation into managing our forests. We look at that side by side with the costs of wildfires. We look at that side by side with if there's a wildfire that causes us to have an outage because we lose the ability to import energy over a transmission line. What is the cost of that outage? And so when we start to bring that full picture to bear and understand where we can create flexibility, where there's mutual savings and mutual benefit, it tells a more complete story in terms of those cost barriers. The other item here, renewable energy and co-products. The big thing is that this type of solution, as kind of forward-leaning as SMUD is in this space, it's not something that we on our own can will into existence or wish into existence. If it's the best path for us to get to zero carbon, us wanting it really, really badly doesn't get it there. It does require that full ecosystem. We're looking at opportunities like the Arches project to develop the hydrogen hub as a very, very exciting opportunity, because it takes that ecosystem type approach. It looks at the entire portfolio of solutions, and it lets us, as being a excited contributor, be part of that ecosystem. But it also gives us the confidence that the ecosystem can come into existence, so that when we want something really badly, we also have confidence that the broader industry is there to support us and be part of that journey with us. And then just bottom line, as we think about this technology and moving away from conventional generation, this type of fuel lets us operate with less intermittency. So wind and solar can proliferate further because we have base fuels that can provide baseline generation. Low negative GHG emissions, they're a huge benefit. Wildfire impact, watershed management. And at the end of the day, everything that we're doing affects that local air quality. And so the idea that we're having that public health and safety benefit for our communities is very top of list for what we're trying to do. And this type of technology is very much part of that solution. It was a little fast, but I think I got us close.
Okay, well, we have a little bit of time before we have to break for lunch for 10 minutes or so. Any questions for James? In the room? Elsewhere? There we go. Please.
Julie from Bioenergy again. James, sometimes there's the possibility of a chip, a combined heat and power, along with anaerobic digestion. And sometimes there's a barrier in place as to capping the electricity produced to only power your own facility and not distribute it back into the grid. And I was just wondering about your perspective on that.
So you're talking about the balance between the basically the plant power versus the output of the overall facility?
Right, and whether you see an opportunity for excess generation to be fed back into the grid, or whether you agree that there should be a cap on just powering the facility itself.
So from our standpoint, we acknowledge that we need additional renewable energy to get to zero carbon, and there is a gap, and it's not just we need to get to 3 gigawatts or 4 gigawatts or 4,000 megawatts of generation. That gigawatt hour actually, as we start to talk about this journey long term, becomes one of the biggest concerns. And so where there's opportunities to bring additional kilowatt hours into the system and to bring that energy in, that represents a significant opportunity for us. And so I would say, yes, that's something that we're interested in and encouraging of. It also gets us to a point where we have to think about time of that generation matters. My answer for that, if you're telling me that it's always at 2 p.m. in the afternoon, is going to be very, very different than in a high EV future if you say, I can get it to you at 8 p.m. at night. And so the thing that I would encourage, and really our position on that type of interaction, is that we want our community, our customers, our partners to be part of the solution. And so when there's an opportunity to feed additional energy in, to work with us, to not just feed that energy in, but do it in a way that benefits the utility, the business, and the community.
In a controlled manner.
Yeah. All right. We have 2 from online. One quick one from Gary Darling to James. he requested for you to please share your telephone number for some follow-up.
Can do.
All right. And then another question, this one's for Sam. Let's see, Thomas Grodek from RHST Industries asks, are there any small biodigester prefab units available for small farms like 80 head of dairy cows in order to make it economical? Are there any designs coming up in the pipeline?
I don't believe there are any prefabricated systems for that smaller farm. Many of our members do tend to focus on the larger farms because the economies of scale are just better for those projects. But you can do AD down to very small farms in the developing world and other places. You see it. So unfortunately, I don't think there's anything off the shelf. But I'd be happy to put them in touch with some members who do project development. If you'd like to email me, my contact info was on the slides if you're going to share those.
And all the slides and all the presentations will be available on the US EPA Bioresources Symposium webpage. So they'll all be accessible.
Okay. Any other questions? Well, I guess for James, just what is the single biggest challenge to meeting your 2030 goal, just in summary?
So one of the early challenges, and I think we've done a lot to overcome this, is when you put something on a 10-year timeline from a utility or any type of agency perspective, that's an incredibly short timeline. And so it's required internal learning curves for us to think about how we operate on that timeline. Once we overcome that internally, it still presents an external challenge that we're operating in a world where our timeline tends to be accelerated relative to everyone else's. And so we find ourselves sometimes having conversations that others aren't quite ready to have or don't understand our position in the dialogue. And so building the message is a huge component of that.
Great. All right. Well, I think we about wrapped it up. Evan didn't get any questions after his because we ran out of time, but we have a couple minutes if anybody has a question for Evan. Anybody else? Anything online? Guess not.
I have a question.
Oh, okay. Please.
Hey, Evan. I've been in the industry maybe half as long as you have. Water industry before the compost industry. By the way, I'm Dan Noble, Executive Director of the Association of Compost Producers, which is a sister association to CCC. So collaborating between soil and energy is something that is constantly on my mind. I was teaching circular economy back to high school students in the 70s. So I think we're now really trying to make it happen. The concept is an old one. It's in a lot of the environmental texts. But I think what you've pointed out and what I got from your presentation, even though I know that information, read your newsletters and so on, is how do we build a constituency that really reinforces true carbon drawdown rather than, you know, in the battery world, they ignore a lot of that other stuff. Building a constituency that's well beyond Edgar and Edgar Associates is something that I've been interested in. How would you recommend doing that?
There's been a lot of good policy work on the natural working lands that came out in 2019 that got rolled over to the scoping plan. And one thing that CARB did this year, and this fourth scoping plan I worked on, is that they added natural working lands. Before, agriculture was always a carbon source. And now they realize that agriculture is a carbon sink. And what I'm seeing also at the county level, I was a county engineer in Kern County and Yolo County are two ag counties with great Williamson Act plans. And parlay that into today's climate action plans. A lot of climate action plans came out in 2004 and 06, but now this latest generation climate action plans are kind of implementing this CARB scoping plan at the local county and city level. So what I see in the county of Sacramento scoping plan is they actually have metrics on how much land in Sacramento County were farmed up for capital. You know, we should be, you know, it's a no-brainer. And so Sacramento County has a great climate action plan to actually put the carbon back in the soil. and this carbon farming. So CDFA got crawled back a little. They had 50 million in healthy soil grants that were going to come out and right about now, but it's only 11.3 million that will come out maybe in January, where you get about $50 a ton to put compost on the natural working lands and with some carbon monitoring. So I think we are over the cusp, or finally hit there after a lot of years where the scoping plan recognizes carbon farming. Every climate action plan recognizes climate farming. The Climate Action Reserve, it has Soil Protocol 2.0 coming out because they undervalued compost in 1.0. So the emission reduction factors for compost should be greater if you look at the life cycle of water savings and not using pesticides and fertilizers. So there's a lot more hope. And then what we're seeing, a bill passed by this governor this year was making any corporation who does business in California over $1 billion got to register their carbon footprint, and which isn't, scope 1, scope 2, scope 3. And that's important because once you register it, it's got to be, and the climate registry does a great job. But some of these companies like Apple and Amazon are claiming to be carbon neutral by 2045 too. And they're not part of the regulated community. They're not a cover entity. So they go to the voluntary market outside of carb cap and trade. So looking at the Climate Action Reserve as a gold standard for carbon credits, and was a Soil Protocol 2.0, and with all this action to kind of proving the science with the Healthy Soils grants, I think we're over the cusp where carbon farming will have its day, and big soil is here, because we've been treating our soil like dirt for the last 50 years, and we got to quit that and get the organic matter up to 3 to 5%. So I think we're seeing all the things in play finally. So I think there's hope, and it's right here in front of us by 2030. And we don't have to have a pipe dream or a pipe bomb of being carbon neutral in 2045 with importing a bunch of minerals, and we can't mine our way out of climate change when right in front of us we got farm to fork and all the organics in the world to do what we need here.
I guess that's ending on an optimistic note.
Time for lunch.
Right. Yep, time to break for lunch. Sorry, it's a little bit late, but that's just the way our schedule worked out. We'll be back, at 1:30 or 2?
2 o'clock. Yep.
Okay, great. Thank you very much, everybody, for coming. Appreciate it.
And for anyone in person who's looking for lunch spots, there's one diagonal in Cesar Chavez Park called La Cosecha, and there's one directly across the street called Vila Cafe. I'll be on hot mic duty.
Thanks so much for attending. Like a good event. That first hybrid, that's the. Yeah, no, it seems like you guys are. Someone specific or just really person. Okay. But I'm glad I could be more sort of. Everybody else go well? Yeah. So it was the other side. Okay. Yep. You guys are about. Yeah, good. I like coming to that in California a little bit because it feels like there's still easier progress to make. Yeah. Yep. Yeah. Yep. I can certainly facilitate that. Yeah. I may not be your best, but I can at least start the conversation for you so that the rest can happen. I was going to say, I reached into my pocket and my pocket was empty on my business card. So I'm equally upset at myself. But if you, yeah. Yep. Yeah. Yep. And then it's james.fraser@smud.org. And Fraser is FRASHER. Yep. Yep. I spell that right.
Yeah.
We'll see.
And so you're looking to get some insight into what we're doing around kind of renewables and managing this type of biomass and this specifically. And do you have any interest kind of broader than that?
My manager, 2030 goal, and then we also saw the waste reduction.
Okay. Mike's here, so we'll get going. Michael's here, we'll get going. So we'll go ahead and get started. And for those of you online and those of you in the room, it's my pleasure to introduce Carol Gilland, who has served as the agricultural advisor for the US EPA Region 9. And US EPA Region 9 has been the primary sponsor of this program for the last 18 years. And she's been doing that, Kara's been doing that work since 1921, or 19, well, that shows you how, century I'm still living in, 2021. In this role, she served as the liaison between the agricultural community and the EPA and provides advice on agricultural environmental programs and policies. In addition, Kara works to build collaboration and participation with the agricultural, climate change and agricultural issues, public affairs, and organic waste management. She brings and holds a Bachelor of Science degree in Animal Science from Cal Poly, San Luis SLO. My son was supposed to go there, but decided against it, and that was the worst decision he ever made. Actually, I made it with him, so I have responsibility. And Masters of Science in Horticulture and Agronomy from UC Davis. Outside of work, Kara enjoys cooking, gardening, hiking, and sewing. Kara, take it away.
Thank you, Dan, and thanks for having me here. I'm looking forward to moderating this next panel, looking at water management issues with bioproducts. And I've been here this morning and we've heard a lot about using organic materials, creating compost and anaerobic digestion, creating energy. And this is a little bit of a shift into actually using those materials and using that as a value-added product. And here we are in California. We're the #1 agriculture producing state in the country. We produce the #1 for a lot of different commodity or specialty crops for the country and for the world. And we use a lot of synthetic nitrogen at the same time. We import a lot. And at the same time, we have all this organic materials. We have a ton of it in tons and tons in the San Joaquin Valley that's facing an ag burning ban, complete rule by 2025. And we also see a lot of impacts to water and air quality from synthetic nitrogen use. So we have this really great opportunity where we can put all these materials back to use with agriculture production. So that's looking at this next panel a little bit. And first of all, we have Zachary Tanner, who's going to speak with us. He's from the California Department of Transportation, and he is a landscape architect at the California Department of Transportation. He's worked for over 15 years with both the private and public sector, and he's helped advocate for climate-adapted design solutions and sustainable landscape design initiatives. His areas of interest and expertise are ecologically driven planting designs, promoting sound horticultural practices, and developing water-efficient landscapes. So I look forward to hearing from him first, and then we'll take a few questions from him before we go to our second speaker. So thank you, Zachary.
Okay. Good afternoon, everyone. Thank you. I'm glad to be here, glad to be talking with all of you today. As was noted, my name is Zach Tanner, and I'm a landscape architect with Caltrans down in District 5. We're down in San Luis Obispo. And yeah, today we're going to talk about how we at Caltrans have been using compost in our erosion control applications. I'm going to begin by, I'm going to talk here. Here are a few things I'm going to talk about today. I'm going to talk about the environmental benefits and characteristics of compost. that make it good for erosion control. So these are the benefits of compost as it directly relates to our erosion control applications and a lot of the erosion control work we do at Caltrans. I'm going to briefly touch on some of the legislation behind compost use and basically what brought us into the game, so to speak. Then I'm going to talk about different types of erosion control applications and uses where compost was used. Erosion control is kind of, from a landscape architect's perspective, erosion control is the bread and butter of the work that we do. And for the last 20 years, we've been experimenting with compost and have, you know, a lot of lessons learned through trial applications and different experimental approaches. And we'll touch on some of the lessons we learned, some of those erosion control failures we've learned over the last 20 years, as well as some of the misconceptions about how and different ways that compost can be used. Okay, so the environmental benefits of compost, I know that, you know, a lot of benefits are going to be talked about in the next 2 days. The environmental benefits as it relates directly to erosion control is one that they build healthy soils. So that's a general benefit of compost, but that's a really important benefit for us, as that really helps our ability to establish vegetation. And when we're doing erosion control, the desired outcome is to have permanently established vegetation. That is what we are aiming for. And the use of compost helps build those healthy soils. It therefore helps get the vegetation established on our slopes. And then compost also helps us by protecting water quality. We have large construction sites where, you know, large construction operations, and we have ongoing stormwater mitigation compliance requirements, monitoring stormwater affluent and making sure that we are protecting the watershed. So compost helps aid us in that effort as well. And then some of the benefits of compost as they relate to the physical and chemical characteristics. So I mentioned previously that, you know, compost helps build healthy soils, and it does this through, you know, including organic matter that helps accelerate the natural systems and again build those healthy soils. That's again important to us because it allows for that optimum vegetation growth, and it allows for early establishment of vegetation on our big cut and fill slopes. Compost also protects the soil from splash erosion. I'll show some examples of this in some of the projects that I highlight, but it adds a protective layer on the slope and helps buffer it from any splash erosion that may occur during a rain event. Compost has a high water holding capacity, so it's able to slow down and disperse the energy of any of the sheet flow of water that's running across the slope. Again, it kind of dissipates the energy to help make for a more manageable condition. And it has those natural biofiltration characteristics. It binds soil particles. It has the ability to filter out some of the contaminants that helps with our stormwater quality mitigation and monitoring. And then when it comes to legislation, so back in 1989, California passed the Integrated Waste Management Act. And as Kara noted, that, you know, this helped establish a market for program, and the intent here was to allow for the use of compost to be used in lieu of commercial fertilizers. So that kind of got the ball rolling. And then in 2018, Assembly Bill 2411 was passed. This required CalRecycle and Caltrans to develop and implement a plan to maximize the use of compost for slope stabilization and establishing vegetation. By the time that AB 2411 was passed in 2018, we in District 5 had already been experimenting with the use of compost in our erosion control applications and our construction projects for about 20 years now. Scott Dowland, who's a senior landscape architect here in District 5, he started experimenting with the use of compost in the early 2000s. And so by the time that this bill was passed in 2018, we in District 5 were already off and running with a lot of the uses of compost. But this bill helped spread that effort to a statewide, spread it throughout the state and get all of Caltrans involved in using compost in different erosion control applications. Okay, so now I'm going to talk about some of the projects that we have. This is a project in Monterey County, Highway 101, and it's just north of Prunedale. And you can see it's a large project. A lot of cut and fill grading operations took place. And we were basically working with some very tough existing site conditions. So these are the existing soils. It's an aromatous sand. It's a cross-bedded sand with clay layers in there. And it basically, it's very erosive. And that, because it's so erosive, it's really hard to get vegetation established. And so we knew that we needed to have an aggressive erosion control strategy that got vegetation onto those slopes as soon as possible. And so one of those applications was what we called a compost blanket and coir netting approach. So here you see a big slope. This is a big cut slope. And what we did is we came in and we applied a 2-inch layer of compost over the entire length of that slope. And this is what we refer to as a compost blanket. So whenever I say compost blanket, it's basically a topical application of compost that's usually a 2-inch deep layer of compost that we spread throughout the entirety of the slope. And then we come in and we hydroseeded over that. And then we also applied some coir netting or rolled erosion control product. And the photo in the upper right shows, the success that we had. So this was that same slope the following spring. We had really good germination of the hydroseed. We had really good establishment of the native grasses, California brome, and some of the smaller wildflower perennial species like California poppy. So it's very successful for us. This is the same project, but a different slope and a different type of approach. So on this slope, we applied a compost blanket, which again is that 2-inch layer of compost applied to the length of the slope. Then we came in and we applied our hydroseed. And in this instance, we applied straw on top of that. And then we came on top of that and applied the hydromulch. And this was very successful. This is a very good approach. And when it comes to erosion control, this is a very solid method. I go out there all the time, to this site today, and the slope is held up very well. The vegetation is, fully established and, continues to look great. The only limitation here is, we need to limit it to the smaller slopes, the slopes that are under 30 feet. But where we had those slopes, it was a very effective use. And then similar to that approach was a slight variation. This is a different slope, but here what we did is we applied a 2-inch layer of compost, some hydroseed, some straw, and then we came over that and actually incorporated the material. So you can see the photos on the right show this tracked roller, and we basically rolled that up and down the site, up and down the slope, and it worked that material into the top layer of existing soil. So that way the compost, the hydroseed, and the straw really gets good soil contact with on the slope. And then Once we've incorporated the material, we come in and we hydromulch on top of that. Okay, so this is a different site. Obviously, this is right off Highway 1 on the Big Sur coast. And the Big Sur coast, you know, it's a very tough, it's a tough corridor. You know, the soils are very thin and rocky. They're also very loose, and they're very prone to erosion or slides. So we always need an aggressive erosion control approach, and we need something that gets vegetation established, you know, very quickly in a very healthy, strong manner. So in this instance, what we did is we had a graded slope, and we applied 2 inches layer of compost. We did the same incorporate materials approach that I showed in the previous slide. So that tracked roller, we basically roll it up and down the slope. And again, that helps to work the compost into the top layers of that existing soil. And then we came back and applied, in this instance, we applied a hydroseed. But in a general sense, you could apply any kind of bonded fiber matrix or any kind of hydraulically applied erosion control material. But yeah, here we used hydroseed, and you can see this is the following spring. We had very good germination, very good establishment of vegetation, and a very good, strong, stable slope. We have also used compost in a little more traditional manner in bioswales and stormwater detention basins. So this is a different site off Highway 46 East, and it's a bioswale. So we came in, and the first step was to apply a 4-inch layer of compost. We incorporated that material 12 inches deep. Ideally, when we do the incorporation, we like to incorporate it 6 to 12 inches deep. On the slopes, you know, it's harder to get that full 12 inches. But in this instance, we were able to incorporate the material, the compost, down to 12 inches and really increase the capacity of this bioswale to hold water. And then the last step was we hydroseeded on top of it, and we got great results out of it. Good water, you know, infiltration and water holding capacity at this location. And then we just have those slopes that are kind of brutal. They're really hard from a constructability standpoint. Either we don't have the construction access that we're always hoping for, or we have really thin and difficult soils. And you know, and in this instance, we applied a bonded fiber matrix, which is a pretty standard erosion control product. It had hydroseed included, so it's got some native seed in it, but you know, it was a very difficult slope. However, you know, taking that traditional approach, that traditional erosion control approach, and adding compost into it, I mean, it just further increases our ability to get additional success out of whatever application we have. So, you know, at a minimum, adding compost into the situation always gives us an added boost, even in those very difficult and tough situations. Okay, and now I want to talk about some of, I guess, what we would say the less traditional uses of compost. Jumping back to that Prunedale project off Highway 101, in that project we were experimenting with compost as compost berms, or using compost as compost berms. And compost berms are basically, they're a form of linear sediment barrier, much like a fiber roll, and they're placed horizontal onto the slope at this interval. And the intent is basically these berms are to slow down and dissipate the energy of any water that's traveling across that slope. They are pneumatically applied, so they're blown directly onto the site. You can see in that photo on the lower left. And we come in and we hydroseed on top of that. The photo on the lower right is showing the compost berm sitting over some netting. We've actually changed our approach through the years. We now roll the netting over the top of the berm. And that's because we found that the berm was, as it, the compost starts to break down a little bit more, it also, eats away at the netting below it. So that's why we put the netting on top. But by being able to hydroseed over it, again, we're getting vegetation to establish, we're, kind of further netting everything into place on site. It works really well. Here you see a good example of how it's capturing some of the sediment that was flowing through some, as the water is sheet flowing across or down the slope. It's holding back some of that water. It's holding back some of the finer sediments. And when, for these compost berms, we're using a medium compost particle or a medium particle size. I'll talk more about the particle size later, but basically the medium particle size allows for water to pass through it. It's also, it has some water holding capacity to it. So it's allowing that water to infiltrate on site. And we're getting, a decreased volume of water that's then, running off site. So we're really minimizing how much water is concentrating at the toe of slope. In the lower left, you'll see a detail that shows kind of the basic configuration of the compost berm. They're 12 inches tall by about 3 feet wide. We've actually now necked that down to 2 feet wide. But anywhere about 12 inches tall to about 2 to 3 feet wide will give you this kind of performance. And it's really not so much the shape of the compost berm, it's more about the bulk and the mass of it. You're really just wanting to capture that water before it heads off site. Another use of compost, we use it in what we call compost socks. It's another form of linear, sediment barrier. In this instance, we're using them as a series of check dams. And these are basically fabric socks that we fill with compost. And then we place them, throughout different intervals. And you can see they function just the same as a compost berm. They're a little bit stronger. They allow water, they hold back some of the water to allow that water to infiltrate on site. It holds back the finer sediment, but it also allows some of that water to pass through. So when used, we will sometimes use them at the top of slope to prevent a lot of overland flow onto a slope, or we'll use them at the toe of slope to catch any water that may accumulate at the toe, or we can use them as a series of check dams in a bioswale location. So here I'm going to show some slides that kind of show compare and contrast of how the use of compost in our erosion control outperformed some of the other, more run-of-the-mill erosion control applications. So this is again at that Prunedale site off Highway 101. This was a slope that did not have any permanent erosion control applied. And this was after a good-sized winter rain event. And you can see basically we had a lot of erosion control issues. So no compost was used here, but it was used here, or at least on the top half of that slope. So the top half had it had a layer, 2-inch layer of compost, and then it had hydroseed and the netting. And in this location, we also had some compost berms. Whereas at the bottom, of the slope, it was basically just the temporary erosion control. After that same winter rain event too. So you can see the top half of the slope really did its job and held up against that rain event. Another slope after that same rain event, The area on the right had compost with a bonded fiber matrix, whereas the area on the left just had a bonded fiber matrix. So you can see the area on the right clearly outperformed the area on the left, with the only difference being that the area on the right had compost included. And like I said, we've been using compost, experimenting with different ways of using compost for about 20 years now, and really have dialed in our approaches in the last, 10 to 15 years. And one of the things we learned is that compost is prone to sloughing off. And this usually happens when you've got a really heavy rain event and that 2-inch layer of compost becomes overly saturated and heavy and it starts to slough off the slope. Typically, this is not a problem for us, especially when you think about what would happen to that slope if the compost wasn't there. Because, that 2-inch layer of compost is helping protect. It's like an insulating layer on the slope, and it really helps protect from any splash erosion there. But this does happen, and typically we just, it's a pretty minimal fix for us. It's also prone to rilling. This typically happens when we have a lot of water flowing over the top of the slope. That water starts to cut through the top, layers of the compost. Again, it's not too much of an issue so long as the flows are not concentrated. Really, the weak kind of Achilles heel of compost is when you have on a slope, that is, when you have concentrated flows. Here we had a bridge structure, all the water was being channeled to the end of the bridge structure, and it discharged that to the right at that end of the bridge into that small space there, and then some concentrated flows developed, and it just basically ate away through the top layers of the slope. These are all preventable by controlling how much water reaches the top of the slope, and you can prevent concentrated flows through the use of compost socks or compost berms or even fiber rolls. And compost is really good at handling sheet flow. It's just unfortunately not very good at handling concentrated flows. And some misconceptions. So this is back to the Big Sur coast off Highway 1. This was the Mud Creek slide. You can see, we definitely needed an aggressive erosion control strategy. It's landslide material, so it's very granular, coarse soils. It's really hard to get vegetation established on these kinds of slopes, and they're very steep slopes. And in this instance, we're dealing with sensitive habitats, sensitive, right on the coast, right next to the Pacific Ocean. And so we wanted to make sure that the compost was not sloughing off the slope or blowing into other environmentally sensitive areas. And we know that we wanted to use compost because we just knew that we needed that to be able to get that vegetation established. So working within those constraints, basically what we did is we would apply the compost on a small section of slope and then immediately cover it with hydroseed and a bonded fiber matrix, as opposed to, trying to cover a larger area below the compost over the larger area of the slope and then come back, at several days, because that's several days worth of work, and then come back and, apply the final layers. Instead, we just went section by section and made sure that we did not leave any compost exposed to the elements. And it worked really well for us. So here you can see that same slope, good germination, good vegetation establishment, and we were able to keep the compost on site. We did not have any issues with compost blowing off or sloughing off off-site. And that just came down to how we targeted our application and worked our construction sequence. So even in tough, situations like that, there's typically a way to to tailor your operations to get compost applied. We've also used compost when trying to revegetate an area. This was a informal parking area of Highway 1. You can see it's a very compacted soil situation. And we went in and applied a 4-inch layer of compost, incorporated that 12 inches deep, and hydroseeded it and got very good results out of it. A lot of coastal prairie species, native grasses, and we're led to believe that the success of this was due to the fact that we were able to increase the water holding capacity of the site. Another similar site where we had compacted soils, we came in, applied 4 inches of compost, incorporated it 12 inches deep, hydroseeded it, and had good vegetation establishment. Okay, so as I close up, just a couple things to note here. If you're using compost as part of your erosion control or any other kind of application on a construction project, there are online calculators that will calculate how much carbon sequestration the use of your compost, or how much carbon it sequesters. There's lots of different, I'm sure there's lots of different calculators out there. This is just the one that we've used for some of our environmental documents where we want to know, calculate the carbon sequestration. And I talked about particle size. These are the 3 particle sizes in our spec. And so we have fine compost, medium compost, and coarse compost. Fine compost is used for those soil amendment and incorporation situations. So that would be where, like, stormwater detention basins, bioswales, or where we're trying to revegetate a site where we have very compacted soils. So for those situations, we're using fine compost. For the compost blankets or the topical applications, and also for the compost berms, we're using a medium compost particle size. And then for the compost socks, we're using a coarse compost. And I should note that lately, we've been substituting fine compost in lieu of the medium compost. And that's because it's been hard to get medium compost that complies with our specs. That's basically due to the larger sieve size. It allows for more physical contaminants to pass through. And so, the medium compost we've been having problems with it meeting our spec, but we've been able to get a lot of great fine compost and substitute it that way. And we're also hoping that as compost use increases, a lot of the compost suppliers will be able to produce that medium compost in compliance with our spec. Our spec also talks about physical contaminants. This is important, especially the film plastic. You can see that the fine, medium, and coarse all have the same, less than 0.1%. That's where it gets difficult for some of the medium and the coarse to meet that spec. But it's a very important element of the specification. And our spec basically was developed directly in communication with the U.S. Composting Council specification. And our spec also points back to their STA certification. And so anytime we receive a compost submittal, this is included, and it basically points directly to the SDA certification. And that concludes my presentation. So again, thank you for having me. And I was very happy to be able to talk to you today. So thank you.
All right. Thank you, Zach. That was really interesting. And just looking, seeing our roadsides and our highways and knowing that that's a big consistent market for compost is really interesting to see it used that way. So we're going to do questions at the end and move into our next speaker. And then, yeah, he'll speak and then we'll do a few questions at the end. So moving on and shifting gears a little bit, we have Michael Wolf here from California Department of Food and Agriculture, and he's a soil scientist there who specializes as a researcher in soil carbon and nitrous oxide emissions. He's been at CDFA for 5 years, working on ag climate adaptation and greenhouse gas mitigation issues. He was recently appointed supervisor of the Healthy Soils program, which I think we'll hear more about today, and he hopes to help California create a circular economy for organic resources with a prominent role for agricultural land. So welcome, Michael.
Okay, good to see you all out here. My presentation will be a little bit shorter than Zach's, and it's a little bit elusively titled since the focus will mainly be on water quantity and to some degree on quality effects of the use of compost. But we'll start from the top a bit, talking about the context of the Healthy Soils program. If I can, I suppose it's a down button, and there we are. Okay. So just to orient ourselves, the Healthy Soils program at this point has 3 divisions. One is the direct incentives given to farmers and ranchers. We call the incentives program. Another is a recently created form, which is a block grant pilot program by which people will be applying direct to local organizations which received the money from the CDFA to disperse and work with farmers on a local level. And then there are the demonstration projects, which also include research projects focused on research of particular subjects, and I'll make some allusion to that later. Now, so that means that it's the incentives program and the block grant pilot program that farmers can apply to directly for help in practices like compost. Compost is indeed our most popular practice for application. The second most popular practice is cover cropping, and we often see them combined. Most of the compost that people get reimbursed for using through our program is purchased from certified facilities, but it can also be produced on farm following the rules. So just to give you a quick impression that there are basic guidelines and logs that have to be kept in order to qualify for the incentive support if one is producing compost on the farm. And these terms will be somewhat revised in the RGA, the applicant guidelines fundamentally, that will be coming out in December. And it's worth mentioning that we are trying to smooth the way more for communal, that would be an exaggeration perhaps, but for cooperative, collaborative production of on-farm compost by a small number of farmers working together. Okay, so looking at particularly at the question of compost and in the alleviation of water stress, many farmers have reported this effect. I have to say, I can't see my slides completely because of all the stuff on the screen. Can you give me just a second? It helped to orient me well. Here, that will be a remedy. Okay. So in California, as in other countries, especially with Mediterranean or arid climates, we've heard consistent reports of decreased water stress with the application of compost. That can be very hard to measure, partly because farmers do not run replicated experiments, and partly because it's very difficult to test water stress directly in many crops. These Positive effects of compost are more prominent in poorer soils or soils with lower health or a sandier texture or low organic matter. In California, there has been sparse research, to tell the truth, but we do have a study showing positive effects on the water status of young almond trees in a water deficit situation, and in climes as different as corn in Minnesota. But then as you explore the relevant literature, it really takes us to more arid and water limited parts of the world. A lot of research from the Middle East or from Pakistan. And so we've seen positive effects in tomato, quinoa, pea, cotton. Most of these are significant for the California economy too, and all have shown better plant water status and yield with the same amount of deficit irrigation due to the addition of compost. Now it's not quite that simple, and we'll see some further complicating considerations. We see further benefits with the inoculation of the compost with arbuscular mycorrhizal fungi, which is a mouthful that is familiar to soil scientists, but these are fundamentally fungal networks that can be built into purchased coatings on purchased seed, or they can be put into a compost product, and they, as it were, infect the roots of the crop and serve as an extension of its network for obtaining water and nutrients. So there's really a synergistic effect seen with that, and also in a similar way, although without the networks, with plant growth promoting rhizobacteria, that is to say, bacteria that live in the root zone. The formation of mycorrhizal fungi improves soil structure, and as I mentioned, conveys water and nutrients to plants. We've seen positive interactions with compost and AMF in Egypt, for example, in maize, which of course we have in California. Also, I don't remember where it was. I think it was in pistachio, perhaps that was Iran. And interestingly, in carob trees, in a study that was simulating the recovery from a drought for a tree crop. So that is an important market and practical consideration to bear in mind, because these products are on the market. Other products that are on the market or being produced that are of interest to us would be humic acids and compost teas. I will speak of them in the same slide, partly because they can have similar families of compounds in them, although a compost tea produced on a given farm can be obviously be very difficult to predict in terms of what its chemical composition would be. Humic acids tend to be more specifically characterized by the vendor. Both of these can be applied either to leaves or through irrigation. And it's not a simple picture. There are certainly soil building and soil microbial and soil fungi feeding effects. But there are also physiochemical and metabolic effects of these compounds within the plants, which is why it works to apply them to leaves as well, foliar applications. There is quite a bit of research of this type on the humic acids, less about compost teas, unfortunately. So you can mark it as a point of interest, as I have. But there are several promising studies that have been seen with compost teas. We at the Healthy Soils Program do offer, I think for the last couple of years, we have made available funds for research for compost teas, among other practices, and we have not had takers yet. We have not had proposals. It's not as simple as taking. Okay. So perhaps stepping back for a moment, what are the benefits of compost, and why do they have a significant effect on water in the soil and the quantity of water available to crops? Firstly, we hear from applicants to the Healthy Soils Program that they want to improve the infiltration of rain or of flood irrigation into their soils. That means that they are seeing loss of water and runoff from their soils, and they are diagnosing a need, and they have heard accurately that they can improve the infiltration of water rather than losing it as runoff with incorporation of compost into the soil. Over the longer term, the soil structure will be improved, and parameters such as the old-fashioned tilth, the workability of the soil, or for a scientist, the aggregate stability will be improved. That infiltration is matched by at the same time an increased capacity for retention of water with compost presence, and over the long term with increased soil organic matter, because organic matter itself can hold about 10 times its own mass in water. That's a simplistic way of looking at it, but it also goes improving the porous structure and the aggregation of the soil. There logically, soil organic matter increased by 1% of the soil mass increases water availability by 25,000 gallons in the upper 6 inches of the soil. And these sorts of statistics are often used. At the same time, they have to be taken, they have to be used with advisedly. If we're talking about some Californian systems where someone might be implementing drip irrigation very carefully, and there's not significant percolation of water beneath the root zone, then we can't say that there are these massive savings in water. But certainly when we're talking about retaining precipitation for use by the crop, and creating more effective and even flood or furrow irrigation, these effects are seen. Turning to the issue of soil water quality effects, nitrate content and the leaching of nitrates into groundwater aquifers is a great concern, of course, especially in parts of the Central Valley and the coastal areas. And higher carbon and nitrogen compost can chelate, can bind nitrate, as well as incentivizing the growth of soil microbes, which would then immobilize or assimilate nitrate. This is not an instantaneous effect, but it's something worth taking into account in the nitrogen balance and the overall nitrogen impacts of a farming system. Then in the short term, again, there's quite a bit of literature from parts of the world where salinity is more of an affliction. Compost has been applied in many saline and sodic soils and improves the performance of plants in situations where their uptake of water or the balance of nutrients that they're taking in is stressed by the salinity in the soil. At the same time, to be responsible and consider the whole picture, we do have to say that the use of compost, especially depending on what sort of compost is being used and its salt loads over time, can also aggravate soil salinity. For example, manure or food waste compost can be high in salts, and certainly growers would want to be responsible and careful with analyzing the salt contents of what they're applying and considering how much leaching fraction they're going to need within their fields. But whenever we mention that caveat, it's only fair to mention that these same problems exist with chemical fertilizers. So this is why it's worth mentioning the tremendous undertaking that is being planned by the CV salts planning process. There are horrifying quantities of sodium and chloride and magnesium being brought into the Central Valley every year and staying there. And there has to be a long-term solution, and that is what is being addressed possibly as one or a series of salt drains, salt network, a network of salt drains from the Central Valley in the long term. So it's worth mentioning that long-term perspective as well. That is the end of my observations. I had some help from some specialists on our expertise-rich staff, Shaharuna and Guiwa, and thank them for that. And I'll be open for questions.
All right. Interesting hearing about the black gold that compost is for both erosion control, water quality and quantity, and for agricultural, the potential to use it in our agricultural fields in California. So does anybody have any questions for Zach or Michael? Yes, and I think you want to.
Zachary. Zachary, I appreciate your depth and especially the variety of the images that you've seen. My name is Michael Theroux. I've worked in the space of environmental resource recovery and waste management for far too long. Many years ago, I worked with Caltrans toward use of, at that time, just organics. It was a broader look, and almost everything that was discussed was, it may have been called compost, but it was more appropriately a mulch, just ground wood, basically. And there's still a great need for that kind of material. But I'm wondering where you draw the line. You say compost across the board, and you certainly are getting the kind of growth response that you would expect from a true compost rather than just a wood mulch. Has Caltrans shifted gears so dramatically that you differentiate between the two uses these days?
Yeah, so I would say not much has really changed. When, basically we're using compost, well, let me back up. Our erosion control, has hydraulically applied seed, and that is where we're using a lot of compost as part of that, and it's a mixture. And so the compost is worked into that hydroseed mixture, or the recipe for the application of hydroseed. So we use a lot of compost in that instance. We're still using a lot of mulch. And we're using mulch in more of a traditional landscape installation where we've got trees and shrubs from container stock, basically. We will occasionally use mulch on a slope as well. But again, that's usually when we're working with container stock species. And so for our erosion control, where we're hydraulically applying, seed or a bonded fiber matrix, that's where we're using the compost, and more often than not, we're using just compost and in a hydro mulch. We're not using the more traditional wood chip mulch.
Thank you.
Yeah.
Appreciate it. I have a question for Michael, if I may, and thank you, Zach. That was appreciated. It was a little confusing in that my experience with Caltrans was on the mulch side, and encouraging to hear so much emphasis now on actual use of compost. Michael, are you making a two-part question? One, are you making progress on standards that would include the utilization of biochar into CFA programs? I know you are, and kind of an update to that might help, but it's a huge topic. I don't know how much you want to get into it. And the other question I had to do with the introduction in the food waste arena of meat from food waste. There was a big flurry because of a conflict between federal and state regulations, mostly, I think, in what could be permitted for use in food waste generated compost, as to whether or not meat, there were anything from hot dogs and, on through. So could you address those 2 points? They're kind of tied together.
There we go. We do not regulate what counts as certified compost, and basically what is certified by the CDFA's the bodies or OMRI. That is what we accept. As for the biochar, it is not. We have at least one research project going in biochar. It has been held out of the program until now because we were not seeing increased yields, yield benefits. And in a literature review of Californian experiments, and that is one of the standards of the program. We can't incentivize something that might not be helping yield. It is complex, of course, because when you're putting biochar into the soil, there very well might be an initial period when it's becoming saturated with certain anions and cations, and then it ultimately in a few years it might come into equilibrium with the soil water solution, and no longer have any negative effect on crop development, but instead be providing a buffer for the provision of different nutrients over the course of the year, for example. So we are aware of the complexity of that, and we were looking carefully at different biochar experiments that are being done with state support. If someone wants to purchase a compost with our support that includes biochar, I would just ask them to be in touch with us to discuss the details of that. Thank you.
All right.
Thank you. And I think this was briefly answered, but maybe Zach, you could quickly answer. There's a question online. Did Caltrans use the medium grade or fine grade compost in applying their compost blankets?
Yeah, so the short answer is we've used both. We start off specifying a medium compost for the topical applications or the compost blankets. That is what we would prefer to do. That is where our spec starts. Now, we have been substituting fine for medium because as we get into procuring the compost and getting our submittals, we're finding that sometimes it's hard to have a medium compost meet spec, and that's because the medium compost doesn't always have the requirements for physical contaminants. And in that instance, we will substitute a fine for medium, and basically fine or medium work perfectly well for compost blanket. So it's kind of both, basically.
Thank you. Are there any other questions? Oh,
Zach? Yeah, I was just wondering with the STA certification requirements, do you ever accept food waste derived compost, or does it not meet your standards with regard to contamination?
Yeah. Generally, yes. I mean, we have basically the way our spec addresses it is we have a provision that could say food waste is not to be part of the compost supply. I can't really think, I personally have not had any situations where I've needed to make that requirement. So as long as the compost is adhering to, you know, the STA certification and it meets all the other requirements of the submittal or our specification, we do not, you know, get into that level of detail about food waste. But we can if we need to, and unfortunately, I just don't have any examples of where I've personally done that. So.
Thanks.
And we actually have a couple more questions, Michael. One is, what criteria does one need to satisfy to become a Healthy Soils Incentive Program qualified certified facility? Is your mic?
We do not certify people to produce compost. It's either USDA or OMRI or CDFA's
Okay.
certification. There are details on our website about which certifications are accepted.
Okay, and I think, there's one more question for you, Michael. How does CDFA set the recommended rate of compost at 8 tons per acre maximum, and where did that number come from?
That came from a study which took into account different carbon to nitrogen ratios and how much should be applied to have a positive effect on the soil carbon, soil organic matter levels of a given field. There may be some adjustment to that, but I'm not sure if this question is really aiming at the issue of occasional high concentrations of compost. We hear some stakeholders want to apply, for example, like 15 tons per acre once every 5 years or so in areas that are harder to reach, rangelands fundamentally. And we don't incentivize that at this point. The research is not ready for that, and there are significant concerns about whether it blows or washes away. And so we are definitely keeping our eyes on that issue. Generally, when people ask us that question about going above 8, they're thinking of those situations. So that's why I mention it.
Okay. Great, thank you. Thank you to Michael and Zachary. And I think that is the end of our session. We have a break now, I believe.
Yeah, we have a 15-minute break. We have cookies out in the hall, so help yourselves.
Thank you.
Super interesting.
I hope so.
Yeah, that was exactly.
There wasn't enough solid, evidence to talk about within the program because we don't monitor. Yeah, great.
That's mine.